introduction to SAP HANA. So SAP HANA memory management and data persistence, operations and troubleshooting, backup and recovery. Okay. So, well, when you see the slide, okay, so let's go to this particular slide. So what you can make of HANA? Fine. We all know that HANA as a database. Okay. So I've told you NetWeaver, SAP NetWeaver is a platform on which SAP Business Suite applications, ERP, CRM, SRM, and others have been developed. Okay. So SAP HANA is not only a database. So you see this diagram. So SAP HANA is a platform, the green background in the middle. So follow my mouse cursor. Okay. So the green is an HANA platform. In the middle, you can see database services. Okay. So we know so far that HANA is an SAP database. Okay. But it's a main service, but it has much more capabilities than what more than database. Okay. So it has the capabilities to do text mining. So it has capabilities to do analytics, data models like BW system, where you present beautiful reports, and applications and UI services, nothing but user interface services, Fiori and others where you feed the data. And then you have a business functions library. We will discuss what it is. And then the search functionalities, and then predictive analysis library. So this predictive analysis library is nothing but more or less like an machine learning kind of thing. Okay. With the given data or the data present in the system with the trends, it will try to tell you some insights. Okay. Your database forecast is so and so thing, your database growth is so and so. Next few months, we are expecting you may have to increase it, and the performance analytics. So those things will be presented by this predictive analysis library. Okay. So, and then the most important part, any platform is the integration service. Why anybody releases any software as a platform is the most important thing is the integration. Okay. This is the biggest problem for any organization or any product developers or anybody. Okay. You develop an application. Let's say SAP you have developed, SAP Business Suite. It is working absolutely fine. But if it cannot integrate with anybody else, in the sense like Google or Facebook or mobiles or tablets or whatever, integration is one of the most shout out feature or the shout out thing in any product which you develop. Okay. So SAP's biggest drawback in the market. Okay. You may hear it. So why a lot of people complain about SAP? It's not because of the product is bad. It is not because the product performance is bad, or it is not because there are so many issues. Obviously, there are issues. Without issues, why do they need so many basis guys and so many partners like TCS, IBM, Accenture who are supporting? So there will be issues. If you look at the complexity of the product implementation or the landscape they implement, so issues are going to happen. But many complain, the biggest complaint to the customers to SAP is number one, I told you user interface. Okay, your user interface, SAP GUI has been outdated, and they came up with Fiori. Okay, that we discussed. But compared to the user interface, fine, they can live with that, whatever SAP gives. But the another most important field is integration services, integrations. Okay, so this is the one of the biggest pain point for SAP. So long, it's not even now. It has not been improved so nicely. But still, there is a gap, lot of gap, okay, in the integration. What do I mean by the integration? For example, I have an SAP system, okay? This system has a problem in communicating with non-SAP systems, your mobile application, .NET application, Java application, or something you develop in Google Cloud Platform, or something you develop in the web cloud, Amazon Web Services. Whatever, wherever you develop, so at you try to call the data from your backend business system, backend ERP business suite system, ERP system. Okay, if you don't provide an integration framework, okay, through which you can integrate to the backend system, then all these guys tries to complain because the rest of the IT world, they may not develop in ABAP, right? They have their own developing languages. They have a lot of development HTML, UI5. SQL related, so Java. So there are a lot of development programs. Some will develop in C itself, some Python, some R. So thousands of coding languages, thousands of people will be developing. But there should be an integration thing to the SAP. Okay. So that is why, SAP wants to address many problems in one shot. Again, they have come up with one of the outstanding or the concept or the outstanding platform, which can kick off the entire competition. Whoever is thinking of to beat SAP or to challenge SAP, for example, Oracle. Okay. So whoever wants to get in line with the SAP, literally throw them out of the competition. Okay. SAP HANA platform. Yes, you do hear a lot of complaints about HANA. This is not there. This is not there. That is not working properly. But you look at it. I mean, SAP, no product will be perfect as soon as it is launched. Okay, and and if you take the enterprise level products, if you just take an Apple phone or mobile phone, it is nothing compared to the SAP, right? ERP. You imagine the kind of coding or the level of systems. Okay, your mobile phone is a 4 GB, right? At max 4 GB RAM, and then that is more than sufficient to deal with the data what you have in the mobile. For that itself, Apple, Google, they take years to develop, or at least 1 year to develop an operating system for that. Okay, each new version they take 1 year. But you look at here, so you are catering a service to the entire world and all the ERPs and such as big industries, oil and gas, mobile banking. So everybody has different requirements. So there will be problems. There will be issues, but SAP will, based on the customers' issues, then they will try to address it. So now in 2011, when I was introducing you, in 2011, this has been introduced. Okay, HANA has been introduced. Now we are at 2021, which means 10 years by now. So 10 years, so the HANA has matured a lot. Okay, so I started working on HANA in 2012. I mean, 1 year after my career started immediately. So I was lucky to see from the beginning how the HANA database performs and stuff. But if you look at it now, current version is HANA 2.0 SP05. So they have allowed, they have literally moved around 110 versions so far, 100 plus version, I have to put it, which means it started with the HANA 2.0, SP0, SP1, SP2, SP3, like that, not SP patch levels. I mean, 100 plus patch levels has been given by 2.0 SP5. Okay. Now, the latest version is 2.0 SP5, which is around the, so far, 100 revisions has been done, which means imagine how aggressively, how SAP is invested in it. It's not easy to develop so many unless the company has been interested and they want nothing else to make sure that this product is successful, because it is very, very important for them. So why it is important? Number one, they want to compete. They want to kick out Oracle. Okay, there's no doubt about it. Even in the standard documents also, they maintain O star 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 wherever they refer to Oracle. Okay, so I'll show you in one of the documentation. Even I have put it. I copied from an SAP site. They put literally O and then star star star. They don't want to name Oracle, so they O star star. Then it is understandable. So the biggest thing is they want to compete with database services. Number one. So the problem for them was, I told you, SAP ERP was successful, but they had dependencies over database. Okay, so Oracle was the one of the strongest database. Even now, I mean, you need to have this context. Even not now, I mean, until last 2-3 years back, Oracle was the one of the strongest database in the world. Okay, in the entire database services. So in the year 2012 or 2010, what happened was Oracle and SAP had a very nice partnership. So I don't come into your domain. You take care of the database part, Oracle database. And SAP said, I will take care of my SAP development. I mean, ERP development or business report. So I don't come into your domain at all. So that is what the agreement for SAP and then the Oracle. And even with the Java. Java was an open source at the time. Or it's a small company owned by somebody else. It's easy to manage. What happened in 2010? So Oracle thought, okay, SAP is completely relied on me. I mean, without SAP doesn't have a database. So without me, SAP has nothing. Okay, they are very overconfident. Okay, fine. I mean, in the competition world, these things are going to happen. So Oracle thought, I can take over SAP. I have the entire Oracle database portfolio in the world. SAP is just one of many customers. I mean, one of the products. There are other customers like Java products or Java applications. Some are use Oracle, but enterprise level, such a heavy level, 500 GB, 1 TB, 2 TB of databases only SAP uses. Okay, for Oracle. Rest all are like, maximum 100 GB, 150 GB. Why do you need mobile, such a heavy database? Nobody needs it. Okay. But as Oracle has a strong customer base, so, but SAP is the only one who is using enterprise level databases. I mean, very strong or very big databases. Okay. And that too from Oracle. So Oracle, what they thought is, okay, I have a strong footprint. I mean, database has a footprint and SAP cannot do anything without me. So then they started charging exorbitant money to the SAP for the database. And moreover, they've also tried to acquire SAP. They also, it's just a product, you come to me. So I'm a database, without database, nothing runs. You come to me, I'll acquire you. So then, and moreover, once SAP says, no, I do not want to sell my, company to you, or I do not want to let you to control my company. It is company. And then what SAP said, I will come up, because it's a competition. I mean, it's a very bad situation for SAP. It is completely dependent on that particular database, and they need something to replace, right? I mean, to customers are worried. Oracle also in parallel started developing PeopleSoft. It's again a competition to SAP's ERP. This is not good. When you are when you are partners, you're not supposed to develop something which is already there, competitive product. So then the relationship has been broken. So SAP had to announce something to the market, that or the customers or the shareholders or the stock market, that I'm going to come up with something, or they have to show an alternative, right? So because Oracle started controlling the SAP's decisions, market, everything. So then SAP thought, okay, I do not want to, as long as I depend on any database, the world, it's not only Oracle, any database, I'm going to have this problem. So what I have to do as a market, whether, even though it is difficult, even though I don't have a portfolio, still I have to work on HANA. I mean, a database concept, which is unique to me, which is solves my customers' performance and, many things. So then SAP, that is the initiation for SAP HANA, for SAP. Okay, that is why they triggered in 2011, stating that I have my own database, HANA. So all the customers, it's an hype. We will talk about how it is different from other database. So how powerful it is, why it is powerful, and those things we will discuss. So I hope now you got the context of why SAP has introduced HANA. It is to get rid of Oracle. Okay, it is to get rid of database dependencies on any other, companies. Yes, in this battle, who lost in this last 10 years of battle between Oracle and SAP? The biggest loser is obviously, initially everybody thought the game SAP will lose it, because Oracle is the only database, strongest database, and everybody, even Oracle also thought that the customers will push SAP to deal with Oracle. You got it right. I told you, banking, oil and gas, nobody wants to touch your data on the database, right? Nobody wants to, it's very risky to migrate from one system to another. So you may think that, okay, it's just, even you see copying from your laptop to a different laptop also, you worry so much. You may lose your pics, or you may lose, but here it's like crores of data, money. I mean, data is nothing but money. So there is lots and lots of risk. So so Oracle thought customers will push SAP to negotiate with Oracle. But SAP was like, I don't care. I mean, I will stand with my view, and I'm not going to sell my company. And so who lost in this battle in this last 10 years? Oracle is the biggest loser. Okay. No matter if Oracle couldn't have done that, I mean, whenever they have little advantage over SAP, if they wouldn't have, taken that advantage, so, I mean, advantage or the taking up this, takeover or acquisition kind of thing, aggressive approach, by now they would have been excellent partners. And, Oracle could have benefited from the database, and SAP could have benefited from the ERP. But SAP now completely wiped off the Oracle. So it's not only, you may think that, okay, what about the other customers? Your Oracle, you know why Oracle lost the battle? Oracle could have, the only SAP they lost it, right? SAP came up with a HANA database. But you have to notice one thing. So until now, until SAP, starts releasing this, competitive database, nobody was there to develop a HANA database. Sorry, any database. Okay. There in the sense, everybody thought that, oh, Oracle was the strongest database, and nobody wants to move out of or a database. Nobody ready to move. So there is no market for databases. Okay. See, SQL databases, Windows database, small databases are there. But everybody was thinking, so nobody wants to invest in developing a database. The reason is Oracle is there. And, even I develop some competitive database, nobody will come to me. The reason is, oh, no, data. Data is very important for any customer. Oh, I don't want to take that risk because you don't know whether the new database is stable or whether the new database is secure. Nobody knows, right? So nobody wants to take that risk of developing or invest in developing a competitive database to the Oracle. But when SAP has challenged it with a HANA in 2011, and then in 3 years, yes, they struggled it first 3 4 years, but somehow they managed to move some customers to HANA. Okay, SAP gave free licenses or whatever it is. So they have managed to move some of the customers to HANA. So now what happened? So rest of the world, the competitor ready, these Google, Microsoft, everybody was eagerly waiting how this battle goes and who is going to win. So the moment they see some customers have moved to the HANA, they thought that now the database has been opened for market. So everybody thought that, okay, SQL is an open source. Why can't we develop our own databases? So then everybody started developing their databases. You see in the market now, Amazon has one database, Google has one database, Microsoft has one database. Everybody started developing small database is not a big thing. Okay, you can develop. You hardly recruit some 20 30 people, good developers, SQL developers. They will design a database for you, nice database. But getting the customers is the difficult part. But everybody thought that, okay, people are developing in my Python. Google thought Python, so they're developing fine. Why can't offer my small database to them? I only develop a open source database and give it to them. Or then Amazon also thought that why should I go with Oracle? So until 2015, nobody was ready to invest in the database because Oracle was the only database. Everybody thought that nobody is ready to come to change their databases. But when SAP has challenged and when SAP took over the major, they migrated the ERP or big business. These are the enterprise level. It's not easy to migrate. When they migrated to the HANA database, everybody thought that, there is a scope. There is a big market. It's a myth that Oracle only can rule the database market. So market has been opened. Database developments has started. So now who lost it? So number one, Oracle lost the SAP, the biggest enterprise database consumer of the databases. Number two, the entire market has been opened, and these like the all other people, big industries, all other software developers, they started developing their own softwares. Even if you see backup, recovery, all third-party tools, that the even startups came up for developing databases and support. So this is the very interesting story in the marketing terms. In the last 10 years, what happens? So this context is important for you. So this you will appreciate with this background how SAP was able to survive and how it came up with an interesting database concepts to the world. Okay, fine. With this context, let's see. So since we are in the basic, so I don't want you to, I don't overwhelm you with all these things, spatial search and all these features, but we focus on only database services. Okay, sorry. So database services. In the screen, you can see database services and little bit of integration services. But if you understand this database services, that is more than sufficient. By the end of the day, if you understand HANA as a database, it's like 60% of the HANA database you understood. Rest all are like for developers or the advanced features. More of functional or the development perspectives, all of the rest of them. But the database part is the important part for us. So good. So daily irritations. So when they were using the other databases, so Oracle database, let's say as an example, what were the daily irritations? So suboptimal execution speeds. Because SAP is an enterprise level data. 300 GB, 1000 DB, 1 TB. So I've seen a database of size 10 TB, in 2011 itself. Now I'm working on one ERP system which has got 30 TB of database, 30 terabytes, which is not a small data. Imagine. So, 1 KB of your invoice, 30 TB of data, how many invoices, how much data that system contains, imagine. So the biggest problem is lack of responsiveness. So generating reports, it used to take, BW system especially, one day, 28 hours, 30 hours like that. So, and then unsupported business process, because at the time Oracle was just a database. Okay, it doesn't have, now they have also started evaluating, they also came up with the in-memory technologies, so and so technologies, but now we are not talking about now. So at that point, when they introduced this HANA, so unsupportable business process, because somebody wants to develop on a database itself, somebody directly wants to connect to the database, because every time you connect to application has to connect to operating system, then operating system talks to the database. So this flow latency, I mean, this whole thing will take some seconds of time. Then the end user get frustrated. Okay, so these are the daily irritations, and then the lack of transparency. So lack of transparency is in the database how the aggregations are happening. I mean, the sums. For example, aggregation is nothing but sums. You know, for example, if you want to say from January, we are in September month, August month, August 1st to August 31st, what are my sales and aggregate with my product details. Okay, if you want such a report, you are selling apple, mangoes, or whatever it is. So for each one, you want to know the sales figure aggregations. So those aggregations and all, they are not so transparent, for the end users or the reports. Okay, so and then sometimes it generates an outdated figures, and guessing the current situation also becomes difficult because those with the current last month's trend, so it has to forecast that so and so products has been sold last month nicely, and this is your top selling product, this is your least selling product. So such kind of analytics of the predictive things, so I've shown you in the HANA platform, predictive features also there. So those kind of things are not available. And then reactive business model. So every time you need some feature, then they have to introduce certain thing. So it's always in a reactive model. So if there is some problem, then you fix it. Though there's no proactive or there's no development as such has invested, because Oracle knows that why would they want to invest money when they're getting invest money and resource new features when they're happy with the existing product. Okay, sorry. So competitive disadvantages. These are the daily irritations what they have. I mean, when they were thought. So seem like so SAP complained to Oracle many times. We want this, we want, but Oracle was not in a mood to listen. Okay, because their whole focus was to take over SAP. You got it. So if they develop so and so features and give it to SAP, who will benefit? SAP benefits. What they were thinking is, okay, let SAP struggle, and maybe 1 or 2 years, let SAP customers complain. So then SAP has no other option. Then its value reduces. Then Oracle can acquire and then start developing all these things. So it doesn't mean that Oracle is not capable of developing these things, but they played a very dirty game, if I have to tell at that time. So, I mean, any competitor in the market, like Microsoft also did so many things like that in US, running a monopoly for so long years. They didn't let anybody to be developed. I mean, anybody to come in the market. The moment they see some opportunity, they acquire it. Okay, because if you are a big company, so you always have that advantage. Acquire the startups and acquire the functions, businesses. So that is what, like Flipkart, it's a very good successful thing. Now, what was that? Walmart has acquired it. Okay, Walmart or there's some other company? Walmart only. Yes, they have acquired it. So now Amazon, anyway, they don't sell it. They are one of the biggest retailers. So like that. So any company, whoever is in the market, they try to acquire this thing. So Oracle also played that way. So it didn't work out. Okay, but those were the daily irritations when HANA was introduced. So good. So that time, so before we proceed further, you want to understand something. So database is nothing but to store the data, right? I mean, to go to the data, I mean, one particular file or something storing the data. So how do you store? It's in the, if I have to put it in the hard disk and this thing, blocks, small blocks, which starts writing the data to it. So there are two ways of writing the data: row storage and column store based storage. So if you take this one in an Excel, just try to see the screen. So you have country, US, Japan, UK, and then you have the products column, alpha, beta, alpha, and then sales 3000, so and so things. So if you consider the row storage, which was Oracle, I mean, now Oracle also came up with the column storage when it was the case, when Oracle was the only database who was ruling the market. So at that time, only the row storage was available. Okay, row storage means it will pick the entire row, first row. It's just like that. US alpha 3000. So it takes the row one, US alpha 3000 in the first block. In the second block, it will write US beta 12,000. So it exactly takes the row and then places it writes in the database. I mean, writes it in the file level. Okay. So, and then you have but if you take the column store basis, so what it will do, as the name itself, country. So it will take the country and it will put all the countries over here. It will take product. So product, all the product details here. Sales, you put all the sales over here. So now you, so you see these block level, as I said, it's block level. So how writing happens on the database is first block is filled, then second block, third block, fourth block, like that. It keeps on writing the sequential way. Okay. So we will see the blocks after some time. But for now, you just understand row store means this, column store is this. Now, if you tell me the biggest drawback of row-based storage is, yes, each one has their own advantages and disadvantages. Row storage, search is not so good. Reading. I mean, when you want to fetch some data, SQL statement, present me the sales, what are my total sales data in the last 1 month or last year. Okay. So the row storage will take time. I mean, in seconds, but in column storage, it takes milliseconds. Why? It's simple. So in row storage, if it strikes the first row, then fine. But in row storage, what happens is it has to read each row. Block 1, block 2, block 3, block 4. It has to go sequential. So if there is something at the 100th or 200th block, it has to go sequentially all the 200 block. Okay. But in column storage, the moment you say select my product alpha, just takes it from one column. I mean, indexing is so powerful here. Just it will directly go to the product. So which means you have reduced the sequential. So here it is in second only. Suppose if you say select my product alpha and sales of the August month, or sales, how many sales? So only 2 steps. First block contains country, second block contains product, second block itself is the product, and it will pick the alpha, and then third block itself is the sales. Only 3 iterations. Okay, 3 steps. It has to move only 3 blocks. Block 1, block 2, block 3. That's it. But whereas in a row case, it has to go select country Japan sales. It has to go 3 blocks, 1, 2, 3. Suppose if there are 1,000, so it has to go in a sequential way. So here, irrespective of how many you have, it always have to look in 3 columns. I mean 3 blocks, 3 blocks on the database. Okay. So for now, you try to remember column-based storage is best for reading. Okay, for reading the data, for selecting the data and viewing it. And row-based storage is best for writing. Why writing row-based is best? Because you have to write the data, which means this data is in sequential blocks, right? Block 1, block 2, block 3, block 4. So obviously, whatever the new data you write, you have to write it in the block 5. Okay, block 6 or block 1500 or whatever it is. So it has to go in sequential only. There's no other way. So row storage is best for writing or deleting or updating the data. Okay, for the modification. But selecting, viewing, generating reports, column storage is the much more powerful. Okay, just you keep these 2 things in remember. So as a homework, you can take this as a homework. Understand the row store versus column store. Okay, you will find a lot of videos in YouTube. So just check them so you will understand. So these are the 2 database concepts, how they store the data in the database. Okay, good. Now let's come to the in-memory computing. Okay, so good. 1 second, I'll have water. Before I go and introduce the more HANA related thing. So now you understood the row store versus column store and why SAP had to go with the HANA database. Now let's say in-memory computing. First, this concept also you have to understand before you get a glimpse of what is. Some concepts are important, guys. So writing the data at the block level, storage, and then in-memory computing, and what are the problems they had at the time. Okay, how they address those problems. Then you can connect well to the database what you are operating at the moment. Okay, what is in-memory computing? So dramatically improved hardware economics and technology innovations in softwares have made it possible. 1 second, let me put this slide. Okay. Okay, for SAP, dramatically improved hardware economics and technology innovations in software have made it possible for SAP to deliver on its vision of the real-time enterprise with in-memory business applications. What does it mean? Good. Again, it was an, sometimes fortune favors the brave or some saying, right? So SAP was literally scared. I mean, when they had to when they came up with this kind of concept, so they have invested thousands of employees across the globe. I remember, when I was working in 2012, around 10,000 employees of SAP developers are only working on HANA. Vishal Shikha was leading. I'm not sure if you guys are aware of it. Vishal Shikha is very, very famous person for HANA. He's an Indian guy in Europe. He was driving it, this one, but now he moved to Infosys. He became Infosys CEO. And from there also he spent some 2 years and he came back. Okay. His story is different. Leave it. But he was the guy who was leading this HANA. Okay. So there was a saying, fortune favors the brave. So SAP was absolutely clear about the software components. I will tell you. So row and column store. So SAP thought uh, the initial or the Oracle was a row store basis. So in order to address customers' problem in reading, they want in real time. If a customer wants some report for last 1 year, his sales record, you don't want to run a job and wait for 24 hours to run. Okay. Immediately, the moment you run, I want the data for the last, because you are in a meeting. So CEO is in a meeting and he wants to forecast, he wants to show to the his shareholders or the, customers, these are my sales, these are my revenues and stuff. So he has to do it within fraction of seconds. You don't want to wait, run a job and then do it. Because if a customer has show me the sales for your Apple so and so version, so he can't say that I will go back and then come back. No. So he has to generate it. So it has to be very quick. Reading and selecting should happen very quick. So SAP's concept was very clear. So I'm going to come up with a database, row and column store together. Okay. So I want to hit two things in one shot. So reading a row store will solve my purpose of writing data to this thing. And my database should also be able to do a column store. Okay. Where there is my reading happens very quickly. Okay. And then compression, partitioning. So these are the parts of SAP softwares. So they are clear with that. But in order to handle this row and column store, or in order to handle such a, it has to be in-memory computing. In-memory means nothing, RAM. In a simple terms, RAM. That's it. So if somebody asks you why HANA is so powerful, is you simply the answer is RAM. The more RAM you have in your mobile or laptop, the better your performance, right? I mean, the price of your laptop, the price of your mobile decided by what? It is decided by your RAM and what is this? CPUs. Or in mobile, there is a gigahertz process, 2.5 gigahertz, but terminals are different. So it's like computing one, whatever it does. So it is decided by the price of the hardware is decided by the in memory, how much they're giving, the RAM. Okay. So the RAM, the bigger the RAM, the faster your application, the faster the cache. So everything will be available in RAM and immediately it will display. The more RAM, the better your performance. So you see 16 GB laptop, 32 GB laptop. 32 GB obviously costs you a bomb. And then 64 GB laptop, that will cost you a bomb more. So the RAM, the more the RAM, 2 GB, 4 GB, 8 GB, like the RAMs are there, right? In mobiles also. So the RAM is increased, your price is going to increase. So this is, and moreover, the CPUs. So at that time, in 2011, those times, I hardly see 8 CPUs and 10 cores full bed. Even if you see 24 CPUs, 32 CPUs in your servers, or we can quickly check what is the server's capability of our server. Okay, so let's connect this one. Come on. This has got disconnected. Okay, so LS CPU. So we have one. Okay, this is inactive. Mm-hmm. 1 second. Let me try to activate it. One second. So this one, let's try to log in as root. Password is 2. Let's see. So I think he has changed it. So I just want to show you, or let's go to our other servers. So I just want to show you these CPUs. I mean, how. So new session. Let's take AH8 Okay, so let's see LS CPU. See now you have 24 CPUs. I just highlighted. So, and then you have the cores per socket, 12 cores. So, which means 24 into 12. So, which means 24 into 12. So, it can do 288 processes in parallel. This operating system can handle 288, which is very strong. I mean, very good. So, multi-core architectures has been introduced. So, there was a revolution in terms of the hardware in 2012 and 13, which means the hardware earlier, the small hardwares, 5 CPUs, 8 CPUs, they have moved out of it. There was a revolution in terms of the hardware manufacturers. So they have started developing very, very powerful servers. So 8 CPUs and 10 cores per blade, which means 80 process can do. So massive parallel scaling and with many blades, which means there are lots and lots of processes can run on the operating system. So the hardware manufacturers have started developing or producing very powerful architectures. And another thing is dramatic decline in price for performance. Price for performance means, as I told, performance is nothing but RAM. So the RAM increases, so the price of the RAM reduced drastically. I mean, earlier, just to increase the RAM of 4 GB, it used to cost some crores for the, I mean, servers, especially on the server levels. So that pricing has been reduced a lot. So the RAM size also, I mean, even though now you see RAM pricing is a little bit higher compared to the old, but it is still cheaper compared to 2012 and 2011. Those, if you compare those days, so these days, if you this price of the RAM is, which means very cheap, you know. So the hardware manufacturers has started developing so huge infrastructures. I mean, the big servers with the more RAMs and more CPUs, and their price also reduced. Okay, that is the important aspect you have to consider. Very powerful architectures with lesser price. So that is the one very good advantage for the you know SAP. So row and column stores they can do. They have an hardware technology innovations helped SAP to come up with a powerful software technology innovations, row and column store, compression. I mean, how do you compress the data when you're sending from operation application to the database? And then the partitioning. The better partitioning you do the tables, the easiest, instead of reading a table of size some 1 million entries, it is easy to read a table in chunks. Break the table into small tables, partitioning. Okay. So then whichever table you address directly, the query will go there and it will fetch the data very quickly. Partitioning. And then no aggregate tables. In the sense, database doesn't do any calculations. Earlier, it has to go to the database and then the database has to do, suppose I want the sales report of last month or last 1 year. So on the database, that calculation used to happen. That's why the background job runs for one day. So it will go and it will fetch all the sales records of one day, I mean, last 1 year, and then it will do calculate the sum, and then it will report. These are your sales, and this is your monthly reports, and some format it will display. So these things now the database doesn't need to do. I mean, because if you have a powerful RAM, right? So you can ensure that these calculations, everything happens over the RAM. I mean, on the RAM itself. RAM is if you have more RAM, it will calculate over there on the fly. It will generate the results. So I will tell you how this problem has been taken care by HANA, but and insert only on Delta. So you don't want to insert everything to the database. Okay, only Delta. So for example. You just want to insert only whatever the changes happened last 2 hours or 3 hours. You don't want to take the entire thing and replace it on the database. No. So these are the beautiful innovations in the software terms. hardware technology innovations, SAP didn't do anything, but it has assessed that it is going to be revolutionized. I mean, they knew that they're going to come up with a very strong hardwares. And how do I take the advantage of those hardwares? By coming up with these kind of these kind of software innovations, So these software innovations cannot work with less powerful hardwares, because so for these innovations to work, these software innovations to work, it needs a very powerful hardware which has a lots of CPU, lots of memory, in memory, okay, RAM. I have to tell you. So that is what, combining these two, SAP has introduced the HANA database, HANA platform. Okay, so this is what you mean by the in-memory computing. So which means everything runs on the RAM with the too many processes or the CPUs available. Multi-processing happens very quickly. Okay, good. Now, before we, again, what were the problems? Fine, we discussed about what is in-memory computing, how SAP addressed the problems. Okay, what they had it before. So the past disk-centric or singular processing platforms. Okay, that was the until 2010. These are the kind of databases everybody uses. For example, CPU. This is the CPU. You have a CPU, and then you have the memory. Okay, which is RAM, and then you have a disks at the bottom in the diagram. You see it. So let's do this thing. Let's go to the screen. Okay, now you're visible. CPU, first, whatever your application requests, CPU and memory has to handle RAM. But everything will have to go to the disk. Disk is nothing but where your actual data in blocks it will store. So long online transactions and batch process, lack of flexibility for business users, complex and costly database landscape. See, the problem is they used to have less CPU, less memory. So for everything, it has to go to the database, disk. So, aggregations or calculations or anything it has to. So now you see the bottleneck here. So the IO bottleneck is the biggest problem.
Hey, ZaranTech now offers SAP corporate training. That's right. Train your workforce in SAP with our comprehensive program. We offer customized courses, certified trainers, and hands-on labs for both individuals and businesses. Our standout features? Bespoke training, fully configured servers for practice, in-house materials, and a dedicated LMS. Plus, get session recordings and 24/7 support. From functional to technical modules, we have got it all. Choose ZaranTech for SAP training and watch your team excel. Learn, upskill, succeed with ZaranTech.
So no matter, even you cannot define a more IO because it has to go with the network and input and output. So that is why those jobs are going to take lots and lot of time, because the database has to do all the calculations and then it has to give it to the memory, and memory will give to the CPU, and memory handles it and then present it to the application. So this is the biggest bottleneck which was earlier existing. Okay, so you may say that that time they can go with CPU or main memory. Yeah, even though you increase memory and CPU, as I told you, that time it was very expensive. Okay, so which means to handle this IO, input and output, they have to go with a very stronger memory. But see, increasing the RAM and CPU doesn't solve you the problem. You got it? So, and along with that, you should have software innovations like column storage, I told you, like partitioning. So these kind of software innovations are also needed, okay, to ensure that you take maximum out of your hardware. Yes, increasing the hardware may help little bit, but it still doesn't solve the problem because everything logic is happening on the disk. Unless you come up, everything runs on the memory, then it is not going to help you, no matter how you increase the RAM. Okay, because you had an excellent server, excellent thing, and if you are running an outdated software or which just will do sequential, then it is of no use because you are not utilizing the server to the maximum extent what it can support. Okay, so that is why these are the problems at the time. So, but the SAP had to come up with something, a complete new technology platform which can solve these problems. Let's see how they have solved. So here you can see this screen. So this will explain you how each of these problem has been solved. Okay. So storage, let's go from or CPU, or let's go from top to bottom. Okay. So earlier they had this CPUs, small CPUs. Now the multi-core architecture has come. As I told you, 24 CPUs in our server, which we have seen, 24 CPUs, each one has 12 cores, which means 24 into 12. So 24 into 12, how many? 288 multi-process can run on the operating system level, which is massive parallel processing, guys. Imagine 200 and suppose if there are tasks happening in the SAP system at operating system level, 288 processes can take over that job. So which is massive parallel processing. Okay. So each one can pick up one task and complete it. So that architecture has come into picture, multi-core architecture. This is what multi-core. And then memory. So what they did, so fine, memory has been increased. I mean, the RAM size is been increased. So now they came up with row and column storage, both. Okay, fine. The inserts, delete, updates, I deal with the row storage, but the selections, I place all my data in the RAM. Okay, I don't go to the database at all. That is what they're saying. See, earlier, so what is this IO bottleneck? So for everything, it has to go to the database. I mean, data disks, if I have to tell you correctly. It has to go to the data disks to do the calculation. Now, I don't go to the database at all until unless it is absolutely needed. I will do everything in memory. See, that is why this middle layer, memory, I will do in RAM. So I store the database, store row and column store in the database, but I will ensure that data is available in the RAM. Okay. And then partitioning. Okay. I will do the tables in partitioning in such a way that the better partitioning you do, I mean, the indexing, so the easy to retrieve the data. I mean, you can address it, call it, and get the data. Partitioning, and then still you have the RAM compression. If you don't do the proper compression, then you need more and more RAM. That is not good. Compression, I'll take care of the compression, and then insert only on delta. So this is the important part in the memory. So what it is doing is, suppose if your database size is a 2 TB, okay, 2 TB of database. So in HANA, you have 2 TB RAM itself, okay, which means the entire DB is running on the in memory, okay, in the RAM, whole DB. So, but there are in storage. In storage, what they're doing is to see how they nicely taken out this IO problem. I mean, input and output. So now your entire database is visible in the RAM. So you only have to go to the disks. One purpose. One is the persistence purpose. I will talk about it. Persistence. What does it mean by persistence? Yes, even though you have in memory, suppose in case of power failure or the crash, so you need the persistent data, right? I mean, to recover to the old state. So that is why what it will do is from the in memory, it writes the data to the devices, storage disks. Okay, just to have the data safeguarding. So you can't simply run in entire in memory. You still need the storage disk, but writing to the storage disk is asynchronous. Okay, data. So data is written every 5 minutes. So there is a concept called save point. Again, we will come to that. So it will write to the solid state devices, and so the logging and backing up will run in the flash drives or the HDD. Logging has to be the faster one. Okay. So and moreover, so your RAM is taking care of the whole operations, database operations. So you insert only on delta in the sense only the changes. I mean, for example, in the last 1 hour or last 2 hours, whatever the changes, last 5 minutes, only those delta you write it to the database, which means very less IO. Okay, from the RAM to your disks, there is a less IO because only delta you are inserting that to every 5 minutes. And moreover, that does not impact the performance of the end user because end users request is taken care by the CPU and memory is taking care of those requests. So this memory to the how it is writing to the hard disk, it doesn't matter to the customer. Anyway, it is not happening live. Every 5 minutes asynchronously, it is writing the data or only taking the delta. So whatever you need for now in this fraction of moment, you have everything in the memory. And the pump from memory, it is taking to the database asynchronously after every 5 minutes, insert only and delta. Only those delta changes, it just copies to the storage disk just for persistence purpose. I mean, in case if there is a power failure or if the system crash, then you have in the solid state disk, when you start the database, it will again memory fills up. The database views everything copies to the memory. But we will talk it. Those concepts also I have slides. So you understood now how the problems of earlier were solved by the HANA. Guys, yes or no? Could you please answer? Did you understand this part?
Yes.
Good. So Fine, all of you are understanding. So how many we have? 14 participants. Good. So guys, this is very important. These basics. The reason I'm telling you is irrespective of your database. Now Oracle also started coming up with because they have powerful hardware. Hardware is there, so they can also come up with similar architecture. They also did it. So now Oracle also has column and row based storage. Oracle also has all these features, and then the Sybase. So irrespective of your database, the concepts are same. Maybe HANA has much more advanced software related, but writing to the database or the disk level, storing the data and the log backups. So these are all concepts are same. Okay. It is just that processes are different. So if you know one database, either Oracle or any other database, if you know one database concepts, rest all are the same. It is just that the tools you use and the processes you operate are different. You understood? So and sometime we will focus more on HANA because SAP's way, and you already know many customers have already moved to the HANA, and there is only one database available in the future for SAP, HANA or Sybase. Sybase is also an SAP's database. So, the that we discuss when it comes to the Sybase concept. Okay, for now, HANA is the most important database when if you want to grow your career as the SAP consultants in future. Okay, so that's why we stress a lot on HANA. Even in tomorrow also Sybase. Wherever I talk, I'm going to talk only the delta amount. Delta. What is something different from Sybase compared to HANA? So common topics, we'll leave it. Because there's no point in again in the name of Sybase, I explain the same concepts to you. Okay, it's unnecessary waste of time. Okay, so please focus on these concepts. Very, very important. Okay, so this is the future, or at that time it was the future. Now it's already implemented. Okay, low latency computing driven by in-memory technology. Low latency. See now, memory CPUs takes care of the everything. So there is nothing goes to the bottom database. The storage disk or anything. Everything happens in these two layers. So, but persistency purpose, the delta changes will be copied to the storage disks. Okay. So that is why HANA is the most powerful database in the world now. Okay. Even if you ask me which is the fastest database, which is the HANA only. Because even though you have other databases, given the data size, I am saying, if you have a 2 TB of database, 2 TB of data size, and if you put any other database, they will not be able to perform as fast as HANA. Because these enterprise databases, enterprise level data or such a huge data is only available with SAP and SAP systems. So no matter what database you put, they cannot perform as fast as HANA. Okay. Yes, it has its, I don't say that it is a perfect database. It's not fair to say it's a perfect database, but it is the fastest database. Okay. Fastest doesn't mean that it has a good performance. It is stable and good. You getting my point? So the fastest one, the moment it hits, some accident, then it has a serious implication. Same is the case with the HANA. So it is the fastest, but it has its drawback. In terms of the stability and problems. But now they have sorted out, those problems. So I'll tell you when it comes, when the context comes, why this is the stability and drawbacks whenever the slide comes. Okay, good. For now, you just understand. So doing it in memory is not always good. Okay, it has its own drawbacks. So let's go to the next slide. Good. So now SAP HANA, as an appliance or the database. So we talk only HANA as so multi-node configuration. You just keep it aside. You just focus on this green background. Green one. Okay, single host configuration for now. So SAP HANA database. This is the most important one. We are focusing on only the database, but it has a lot of services which I've shown you. So it has name server, master index server, statistics server, access server. Just know these names, okay? These are what, if you just go to the HANA and if you check it, these servers will be there. And then SAP host agent and SAP HANA database lifecycle manager. These things you keep aside. So, but these are the most important: name server, master index server, statistics server. So what I'm talking is, let me connect to the studio and show you so that you have an idea of what we are going to talk. Cancel. Okay, for example, we have an HANA system in Studio. I'll show you how to connect and stuff. You just click on landscape. So you see here, you see compile server, daemon, index server. This is the most important one, index server. So it is taking the more CPU and more memory. Just keep an eye. That's it. So you don't need to understand anything. So you see this one, and then name server, preprocessor, a web dispatcher, access engine. So index server is the one which is taking the more CPU. So total 36 CPU and 25 it is consuming. And in memory, if you just place it over here, sorry, okay, come on. Here you can see used memory. This one 29 GB it is used, and peak memory 30 GB. So which means this is the top consumer of the RAM. So what we are talking about here, memory means RAM. Okay. So now you got, this is what I mean the HANA architecture. I mean deployment overview. So this is what. So in an HANA database, you find these names, name server, master index server. So what does this name server contains? Maintains the landscape information. Okay. So there is no easy way for me to explain, guys. So it's an architecture. So you have to remember this way. And if you work on it, then you remember by default. Okay. So there's nothing I can explain over here. It's just an architecture. So you have an index server. So holds data and executes all operations. So index server is the main one. So which holds the complete data in the memory and executes all aggregations, sums, minuses, subtractions, calculations, everything done by the index server. So statistics server, as the name itself, it's just the performance data. And access is service, so it's for the integration. So if somebody wants to develop some applications which will directly connect to the database, so access engine take care. So for the simplification purpose, let's not talk about these things. SAP host agent, nothing but, so it enables a remote start and stop and certain level of monitoring as well. Okay. So these things, lifecycle manager, it's simple. I mean, software updates, HDB LCM, lifecycle manager. Okay. Which means from 2.0 to SP5, SP5 to SP6, if you want to upgrade, so you have to use this one. So these are the main components of the HANA database. Okay. So, and then if you have a multi-node configuration, a node 2, you have name server and index server. That's it, only two. So statistics server and access server, only in the master server it is available. I mean, in the, like we have a central instance and application servers, right? So like this here node, master node and slave nodes. I mean, if you have a multiple nodes, scale out. So in HANA also scale out is possible because there is a limitation for the RAM. Okay. So at the moment in the market, I think maximum RAM which is available is 4 TB or 8 TB. Okay. So if you need more than 8 TB of RAM, what do? So you scale out. I mean, you put another 8 TB server, another 8 TB server, like that. So node 2 define 8 TB, node 3 define 8, like that, n number of nodes. So what is the beauty here? So you can extend the RAM whatever you want. 30 TB or 100 TB, whatever you want. You put the number of servers. So that's why node 2, node 3. So index server is the main important one, which will take care of your calculations and stuff. That's why index server has to be there in the each node. And the name server also, because it contains the landscape information, you need to have the name server over there. Good. So you can see at the bottom, so shared persistency for failover and recovery. Okay. So what it means, disks. Okay. HANA database, these are the things, main, this is the simple architecture if I have to put it as a database. Number one, it has these servers on the master node. And if it is a multi-node, you have node 2, node 3 with name server and index server. And each shared persistency for failover and recovery, which means data disks. I told you. So in this diagram, where is this one? Yeah, in this diagram. So from the memory, it has to write to the disks, right? I mean, so that happens in the data disks. Good. So this is the simple architecture of the HANA. Okay. So again, here we will not focus anything apart from the database related. Okay. So again, here they're trying to, we are trying to stress out what it is capable of. So as a platform, it is capable of open standard interfaces supporting all types of devices. I told you any platform or anything, whatever you develop, it should have a strong integration. Okay. So that is the first one. SQL, MDX, HTTP, OData we discussed, HTTP we know. So any kind of any device, so it has an integration technology platforms. Okay. And then, so integrated application server components. So which means again, this will take care of the integration from all these client devices. Sorry. So 1 DB for OLAP, OLTP workloads. So OLAP and OLTP, do you know? With built-in functions for data intensive processing. So which is nothing but row store and column store. Okay, OLAP, OLTP. So see, OLTP means transaction-based mechanisms. So ERP system is a transaction-based system, which means there are a lot of read and a lot of writing, inserting, deletion, updates in your OLTP. So transaction-based systems. So where writing is more important. Okay, for that, what you need to have row storage. So OLAP means performance, BW, where you have to generate reports, where you have to read a lot of data. So they're OLAP. So in HANA, I told you row store, column storage, both are there. So they solved both the problems. I mean, each system, which wherever there is a HANA, it can do transaction OLTP, transaction-based thing, writing and deleting other things. And it also is capable of doing giving an excellent performance. I mean, by generating reports, reading data. So that is what they're able to do. I mean, it can do. So data persistence and integration. So data persistence means writing it to the data to the disks from the memory. Okay. So again, once you write the data, so it also has the mechanism to connect it to the big data or analytics or data, Hadoop, because you want to analyze the data. If you have a 30 TB of data, you want to run certain queries and make it insights or predictive, those things you want to do. That integration also should be possible. It's not only the SAP's developed tools, other tools, that is possible. Okay. So this is the SAP HANA as a platform. These are the capabilities what HANA, everything in one place. But our most focus would be the middle one, white layer, database part. Okay. So this is the component architecture overview. So what we do is 10:20, we take 10 minutes break, or 10:20, we will reassemble. Okay. So then we will continue with this. Clear, guys? Are we good? Are you following? So, yeah. I mean, if you think that you are overwhelmed by the content, or I'm going a little faster, just ask me. Okay, I'll go a little slow.
So good. We have everybody. Yes, we have. So 14 people are there. So component architecture view. So when you deploy, as I said, HANA is a platform. It's you have a lot of options. What to deploy, what to not. So just focus on the middle part. HANA database, it's one of the platform part. Okay. So SAP HANA database. So this white one boxes are there, right? They're all related to the SAP HANA. So SQL, and then database services, stored procedure, data models, text mining, search. So this you have to copy. We are going to cover. So rest all front end, you have HANA Studio and clients and some plugins, INA toolkit, Shine demo. So these are all the GUI kind of UI interface tools, or the client-based tools, or the front ends. And then SAP HANA as a database, and use case dependent HANA plugins at the bottom. Okay, AFLs, LC apps, Smart Data Access, INF file loader. So these are all based on the requirement or the customer's requirement. If they're SCM, they use something. If they're working in some functional areas, so they will put some plugins. Okay, but as a basis consultant, our scope of support is only in mandatory SAP HANA DB server packages, HANA database, and SAP HANA client. So this is what is relevant for the basis guys. Okay, this is just for your information. I have also added the content. I mean, in case if you want understanding what is Shine, what is this procurement model and all, but it is relevant for our discussion now. Okay. So, I mean, you don't work it in a day in, day out. That is for your, I don't think they will ask in basis administration certification also, just for information. But HANA as a database. So whenever you take HANA as a platform, database is mandatory. I mean, every customer has to take database. That is why they put here mandatory SAP HANA database. Okay. That is why everyone knows HANA as a database instead of HANA as a platform. You got it right. So, I mean, whether you may take it or not, other functionalities, okay, whether you use it or not, but database is mandatory. So if you subscribe for HANA, which means database and then the HANA client will come by default, mandatory wise. So most of the people uses these two. And our for basis scope also, these two only falls into the category. Let's go further. So deployment landscape example again. So let's say you have taken the HANA platform. So the green background. So as I said, DB is mandatory, database is mandatory, rest all are optional. So here it's just trying to say that DB connects to all other third-party tools, text data, Hadoop, and that integration is possible. This is what it is here. It is trying to explain. So wherever you see, you can integrate with many applications, irrespective of the devices, tablets, everything. So it's just a deployment landscape example where you can connect to the web client or your laptops or your all the database. Database connected to so and so things. Okay, just to make your understanding clear. So HANA as a platform, DB is mandatory, and these are all the tools which it can connect or integrate. I told you, integration is the SAP's biggest drawback. Okay. I gave you context also. Most of the customers after the UI, UI is also integration is the biggest problem. Why SAP's integration is the biggest problem? There is one thing, SAP also, there are problems internally, within SAP. So each development, it's a development organization, right? Each development architect thinks that he's the superstar. Whatever I develop, because that ego or everybody, whoever is an expert or an architect. So he has that kind of feeling that my software or the one which I design works absolutely fine. So in SAP also, there are super architects are there, but each architect will have different opinions and different way of working. Some guy is favorable to Java, some guy is favorable to UI5, some guy is favorable to some other thing. So they develop each component or each thing in a different way. So now what happened? The integration is problem. Now SAP will bundle it and sell it to the customer. So customer is the one who is struggling. So that is why you hear a lot of complicated problems. So SAP is not integrating, or I'm not able to connect to SAP. See, my application is incompatible. So these problems are coming because internally SAP developers are doing, in their own way, developing whatever they believe it is stronger. So they develop in each different category. So then the other applications are unable to communicate. So it's an internal problem for SAP. They are also working on it. So, but you see, integration is the major problem for SAP. Even now you say, out of 180 customers complain that, I'm not able to integrate properly. Okay. So you see, the integration is excellent with Microsoft. You see, if you install your Windows operating system, your single sign-on to SAP systems or the Google logins or these things, password saving and all those things. So, everything works seamlessly, right? Tuck, it saves the password and it launches. So that integration, different applications, how you can integrate to your laptop. That works very well with Windows. Microsoft is very good with that. So all their products, Microsoft products itself. So like Power BI or the Teams, Outlook, I don't know which tools you use for mail communications, or the Skype also Microsoft acquired. Now on top of it, they'll develop Microsoft Teams. So they all integrate nicely. Outlook and Teams can communicate nicely. But in SAP, the problem is, it's not only the third-party applications integration. SAP's own products also, they don't integrate themselves. You're getting the point, what I'm trying to say. So SAP ERP and SAP S4HANA Cloud. Okay, there are two different products. S4HANA Cloud system doesn't connect to the ERP system. You understand? So integration doesn't mean that only to the third-party applications. Internal, their own products also do not talk to each other. That is the problem. So the problem is coming because of the development. So that guy would have developed in a different architecture. This guy would have developed in a different different platform, and they don't talk to each other. They don't have a framework to communicate to each other, those two systems. Okay. This is what I mean by integration. So the customer's complaint is, forget about our third-party applications, your own systems. You have some 40, 50 of products, right? Your own systems are not communicating to each other, and there is no way to integrate to each other. Okay. That's the biggest problem for SAP. This is happening because of, individual people, architects, they're developing their own thing. Okay. That is what I mean by the integration is the biggest challenge for SAP. Okay. So that they want to address using this HANA platform. Where they have given the framework for all open source softwares and other things, they have opened up. That is what this slide. Now, again, use cases at a glance. So HANA as a platform can be used for multiple use cases. Okay, HANA platform for database use case, and business one for small scale, middle one, this one I'm talking. Mouse, follow my mouse. Business one on HANA. So it's a small scale industries. Business suite on HANA. This is the most important. This is what we are going to focus. Business suite on HANA means so ERP on HANA, CRM on HANA, SCM on HANA, SRM, PLM, VDL, these are on HANA. So our BW and apps. So this is our use case. I mean, what we focus. So once, if you know this one, this is the main one. In the sense, this is the strong use case where the entire enterprise data will be placed on the HANA databases. Okay. So rest all are for your information and different use cases. Cloud on HANA, BW on HANA, separately you can do use cases. But our use case is business suite on HANA. Okay. So, and then side by side scenarios. I mean, along with the HANA, you can have SRM, CRM, side by side scenarios. I mean, you have already existing system, but you can have an HANA as a separate database for doing your calculations and stuff, and that leave it. But this is our strongest use case, this one. Okay, business suite on HANA. Now, SAP HANA information sources. So once you go home, you try to open these links. I mean, http help.sap.com HANA. I have shown you also. Okay, in this, the most important one is the HANA administration guide. Okay, HANA administration guide, that is the most important one. So you go and explore that document. You will get a 500 to 600 page document, which will have the entire document. Okay, just follow these slides and go to this slide. So, and then HANA content location. This also I have given you. So latest documentation on HANA, you can find over here. HANA sizing, you can find over here. Sorry. So all the documentation related to the SAP HANA has been maintained over here. Okay. So, but all of them is not relevant for you. So you just go with the HANA administration guide. Okay. The first one. Okay. In this also, you have the HANA administration guide once you go there. Good. So SAP HANA curriculum. So the first one is relevant for the basis guys. So here SAP HANA administration and operations. This is just for your, as I told you, SAP is completely moved to the HANA. So slowly they will migrate all these Oracle and DB to all the databases to HANA. So which means the future of the database is this one. So basis guys, you have to focus on this one, administration and operations. Rest all for the other developers. Modeling. Second one, implementation and modeling SAP, it's for development, and they are relevant to their functional areas. Okay, but for us, the first one is important. Good. So again, SAP HANA administration and operations courses. Okay, so HA 200 is the course name. If you want to get certified, so this is the certification you can do. HANA Tech 151. Okay, this is only meant for the HANA. So you have to read HA 200. You see the screen. HA 200, SAP HANA Operations and Administration. And then you have HA 250. So these three books you have to read. Authorization, Security and Scenarios, Migration to SAP HANA using DMO. Okay, these are the three important. But the administration purposes, HA 200 or the SAP HANA Operations. So in this book, I am covering almost 3 units. Okay, these are the major units. So in this training, sorry. So in this training, I'm covering almost 3 units for this HA 200. Maybe once the advanced comes, another 3 to 4 units. So which means you have the training. I think I've got a request, but let me finalize it later point in time. So there I will cover another 3 to 4 units. So by then you will become comfortable with this entire HA 200. I mean this administration and operations. Okay. So modeling course, this is not applicable, just for information. If in case if you change your career to the modeling or the development, okay, these books are important. So HA 100, HA 300, HA 360. Okay, good. So fine. So now, so far what we discussed. So we discussed about SAP HANA, the reason for SAP HANA, why SAP had to introduce. What were the problems the customers were facing earlier? How SAP has solved with the in-memory computing. Okay. And we have also seen the architecture of the SAP HANA and the use cases of HANA, but we are only focused on SAP Business Suite on HANA and what books you have to read in case if you want to master. Administration and operations is the book which basis guys have to focus. Okay. And in that 3 or 4 units I'm covering now, and rest all we will cover when the advanced course starts, or I mean, for your first 1-2 years of experience, this should be more than sufficient. Okay. So, I mean, it doesn't mean that you have to read the book to work. Okay. So without reading the books only, I started working on these systems. So that is there. That is always there. Okay. So, but for theoretical understanding, you need. So that's what we discuss now. Now, what we're going slowly, how I will introduce you the architecture and then scenarios. I've already given you some overview of the architecture, scenarios, and then we discuss about starting and stopping and then backups. Okay. So for that, to be clear, you have to understand some architectural concepts. We'll go there. So what we're going, components of memory management and persistence in the SAP HANA database. What is the persistence? What is the memory management? HANA memory usage and allocation behavior. So row store, column store, which we discussed already, explain how data is persisted in data and log volume. This is also important. Identify optimization with regard to memory management. So this is related to persistence again. Describe the elements of SAP HANA platform. And it's not so elements already we discussed so many things it can do. I mean, the deployment overview and that I've seen integration. So there are so many third-party applications which are possible to integrate, but we are interested only in database as a service. Okay, perfect. So now SAP HANA database architecture, core processes on the SAP HANA single node instance. But anyway, whatever is the node, this is how it looks. So this we have seen in the system. So what are these services? So you can see compile server, daemon, index server, name server, preprocessor, these servers. Okay. Now daemon. So daemon in anything, in any operating system or anywhere, daemon is nothing but starts all other processes and keeps them running. So for example, by mistake, you have killed one process, I mean index server process. So the daemon will immediately start it. So let's go to the server. Okay. So ls minus ltr. Okay. ps minus eaf. grep da grep -i daemon. See a daemon? Yes. See the first process, daemon. Okay, I highlighted it. So daemon is nothing but su-hdb info. su-hdb adm. Okay. So how do you check the info of your system? HDB info. Okay. So you see HDB name server, compile server, preprocessor, index server. All these servers are available. These are the basic processes. If you want to say if your HANA is running or not, you need to see these processes. So the mandatory server is index server, which has to run. Or you can see from Studio. If you don't want to complicate yourself, you can come here, see the daemon. So daemon you have, the most important is index and then name server. So these three processes for sure you need to have. So what this daemon will do, if somebody kills this preprocessor or web dispatcher or access engine, so the daemon will start automatically. So which means it keeps on monitoring all the processes. Okay. Index server. So as I said, yeah, you can see the diagram also here. This is what I am referring. Index server, the main database process. So this will do data load, queries, calculations, and so on. So name server. So statistics server, I told you, it will provide you the, you see in this screen, you don't see the statistics server. So what they did is, number of processes have increased. So this statistics service, they put it in the index server only. Okay. So earlier we discussed it, but index server will do a lot of things. It's the main process. Ensure that is always up and running. So name server, it knows the DB landscape and then the data distribution. So it just understands the landscape. Okay, what do you mean by landscape information? Whether my system is a single host database or a multi-host database, what is my master node? What is my slave node? Is there a DR scenario is available? What is the high availability? So that kind of information is available in the name server. And then preprocessor. Preprocessor is nothing but feeds the unstructured data. So which means it reads the text data. So I mean, how to make graphics out of the text data, such thing will be done by the preprocessor. Compile server performs the compilation of the stored procedures and programs. So like in SAP terms, if I have to tell SGen, okay. So SGen, what it will do? It will compile the program, okay, initially. So the same way it will compile the programs. Like C also there is a compiler, right? So once you put the code, it will compile. So access engine, so this is for the communication externally. Web service component, web through HTTP, HTTPS, you can talk to. Web dispatcher, I've explained you. All the web traffic comes through web dispatcher. So HANA also has the web dispatcher. So SAP start SRV. So start SRV here, bottom three. Start SRV. So it is responsible for starting or stopping the system. Okay, it's the same way like ABAP system. Okay, so these are the processes in a HANA. Process exists in a HANA database. So there is no other easy way to remember anything. You have to know it. That's it. So these are the processes. These are the things they will do. Okay. So I mean, when you work on the system, so you will remember them by default. But this is how, as it is, what they do. Good. So what I told. So the most important process, one second, this one, let's put it to the big screen. Yeah. So the most important process is, I highlighted here, index server. So, I mean, if I show you live, you can connect better. So index server, you see, it's the master node. Okay. So you have more CPU, more RAM, this one. CPU and then RAM. Guys, can you see my screen? Hello? Can somebody acknowledge?
Yeah.
Yes.
Okay, good. So, as I told, index server is the most important one. It will do the data loading, I mean, from the disks to the in-memory. So that is what index server will do. So it loads the data from the disks to the RAM and then a CPU. So it will do calculations, everything over here. This is the most important process. So that's why now this is the overall architecture or the process exists in HANA. So it is important for us to understand index server architecture. Okay, that is what I'm coming now. Index server. So architecture of the SAP HANA index server. So here again, simple, how the index server will do this loading faster and all these things, simple. You remember like this. So it has an SQL interface or external interfaces or a web interface, whatever comes to the index server. So it has the programs available in this one where it can facilitate. I mean, as a basis guy, you don't have to understand first of all, I have never seen the exact architecture. There is no way to check it. Just that information, I know that index server can do these things. I mean, it will allow the traffic, web traffic and everything, third-party traffic. And it will do calculations. So OLAP engine, I told you performance, reading data OLAP. OLTP is for the writing and inserting. And then it has the, calculation engine, so which will take care of all the calculations. So it has a row store. So row store engine will take care. Column store is taken care by the relational engines. Relational engines take care column store. So this is oscillating like this. Column store and row store. So and then because index server takes care of all the in-memory operations, right? And from the in-memory, the delta changes. It has to write it to the disks. I mean storage disk. So which is data volumes and then the log volumes. So data volumes is asynchronous writing. I mean, as I told you, asynchronous means the changes, whatever you are doing, they are available in the in-memory. But every 5 minutes, the delta inserts, it will take it to the data volumes, through save points that we will discuss. And the logger is nothing but whatever the changes you are doing right now, right? If there is any transaction you are executing, everything will be tracked in a log volume. Because if there is a power failure, so this data volumes writing is, before, 5 minutes, every 5 minutes. What happened to this 3 minutes? So those changes will be available in the log volumes so that it can restore to that, recover to that particular log immediately when you start the system. So the log volumes is a synchronous writing. So as and when memory changes are happening, right? As and when in memory their computations are happening, it always keep track of those changes, synchronous writing to the log volumes. This is the difference. So data volumes and log volumes, asynchronous writing is the data volumes, synchronous writing is the log volumes. So these are all will be taken care by the index server. Okay, just know that. So if somebody asks you, who will take care of organizing the data in memory, row store and the data store, which process? Index server. Who will take care of writing the data to the disks? Writing the data to the disks asynchronously, every 5 minutes, the delta inserts by index server. Who will take care of the changes writing to the database, logs? The index server. So most of the critical functions will be taken care by the index servers. That is why this is the most critical process. So if this process is up, then only you can say that your database is running. If this process is down, which means your database is down. It is as simple as that. Okay. So basic need for a database to run, name server and index server, definitely they need to be up and running. Okay, clear? So good. So now let's go to the persistence. what do I mean by the persistence, and we will discuss about it. Good. So I've told you in HANA, everything done by the in-memory. RAM will take care of the in-memory. Okay. So suppose if your database size is 2 TB, I mean, you have a 2 TB of data. So your RAM also will have the 2 TB. Okay. So which means entire database is running on the RAM. Okay. How, as I told you, running in RAM looks fascinating and important. What happens, RAM is like what we call flash memory. I mean, as soon as you, suppose if there is a power failure, right? Power failure in the sense if your HDB database is crashed. So all the RAM data will be gone, right? Because that data is available, that's it. I mean, you cannot assure that when there's a power cut, the data will be cleaned off. I mean, your system resets, like your mobile phone. The moment you restart your mobile phone, your all RAM data or caches will be cleaned up. Caches will be cleaned up when you restart. Okay, that is the biggest problem. So then how do you ensure that you have the data? That is why what happens is from the RAM, all the data will be written to the data volumes, okay, in the disk. So I told you that will be written asynchronously. I mean, every 5 minutes, it takes the delta changes. So regular automatic save points. So you have this memory. You see the screen now. So let me put it over here. Okay. So in memory, the first one, guys, memory, this one, white background and the data yellow. So in memory, you have the data, all the calculations, aggregation, sums, whole thing is happening in this one. Okay. So to ensure that you have a consistent data or the persistent data, from this data, it writes to the disks, data volumes. You call them as data volumes, regular automatic save points, which means in general, 5 minutes is the save point. Okay. So 5 minutes, every 5 minutes, there is one process which will write all the changes or the delta inserts. Okay. I mean, this data changes, data to the data volumes. Oh, sorry, let me go back. Okay, even. So it's important to understand, guys, every 5 minutes, it will check, that process will check, index server, who else will check? Index server will check, oh, what is my data in the memory? So let me copy to the data volumes at the disk level. Okay. Every 5 minutes, the index server will go and check what is the data and writes it to the data values. And then there is one more thing. Okay, every 5 minutes it is running. What about this 5 minutes to another 5 minutes? If there is a power clash, suppose now the time is 10:46. Okay. So 10:45 to 10:50, who will take care? I mean, if something happens, so that is taken care by the log volume. Okay. So log volume means information about the data changes. So whatever the in-memory changes are happening, immediately those changes will be written to the log volume. Okay, clear? So as soon as these changes happening here, synchronous. So immediately those changes happen. Let's say now the 10:46 or 10:47. At 10:47, there is a power failure. Okay, this again I will explain in another slide. 10:47, there is a power failure. So you have a data volume up to 10:45. You got it? So 10:45, there could have been a save point every 5 minutes. And then 2 minutes of data where it is available in the log volume. So it will just do recovery. I mean, you don't see it. I mean, the moment you do HDB start or the HANA start, so it will check for what is my last save point 5 minutes before and what is the time now, 2 minutes buffer. So that 2 minutes changes, it takes from the log volume. So then it will start. Okay, clear? So then you will get to the point in time recovery or exact recovery to the point where it has stopped. Okay, so this you don't do anything manually. So the moment you do the HDB start or the moment you try to start the system, so first thing what it will do is obviously your memory, everything is gone. Okay, so just to consider that your memory is free. I mean, your memory is empty. So then it checks what is my save point, what is the time now. So what is my previous checkpoint? Okay, 5 minutes before I have 10:45. So now 3 minutes. So 3 minutes changes, you take it from this one. That is why log volume is the most important one. I mean, it has the synchronous changes and data volumes are the asynchronous changes. Okay, regular automatic save points it happen. So who will take care of this whole operation? Index server will take care of it. Clear, guys, this concept? Any questions over here? So from memory, this is how your data is taken to the disks. Good. So data volumes. So data volumes are located in the file systems. Okay. So how it writes to the data volumes? So it will write in this red ones, you can see, right? They can be 4 KB, 16 KB, 16 MB. So small blocks. So it will write in the blocks. Okay. So all the data from the memory will be written to the data volumes, and on the disk, it will write it to the small spaces, different page sizes, 4K, 16K, 16 MB, which are arranged in super blocks of 64 MB. That is the maximum. Okay, I mean small 64 MB also small, but that is how it organizes on the disk. Okay, so typical sizing of the disks for data times 4 times main memory of HANA nodes. So what does it mean is, I mean, many people do not follow this standard. Suppose if your RAM is 2 TB for your HANA system, they expect you to have at least 4 times 8 TB of disks available at the disk storage, I mean the server level, but that is not so recommended. I mean, people don't follow. They hardly follow 2 times or 3 times. Okay. Now, let's see the data first of all. Persistent storage, how these data volumes look at the server level. So let us go and find it out. So if you want to see what is your path for your data, where it is writing, so click on configuration. So in HANA, so persistence, so if you just put persistence over here, okay, so this is what we are talking. So everything written to data and log at disk level. All the parameters. So see base path underscore data volumes. This parameter will define where you have these data disks. Okay, it's under dir global HDV data. And where is the log volume? Yeah, base path underscore. So HDV log. So these are the 2 paths. So, and the backups, when we talk about backups, we talk about it, but all the parameters relevant for the persistence are available. Or you do not know, if you don't know this thing. So this is very powerful HANA. I told you, you just come here, you don't know where it is, everything, just put data. So very quickly it will check. So you just know the keyword. Unlike in profiles, SAP profiles where you have to check for parameters so difficult. See how quickly it has shown all the data. Reading is much faster. So base path underscore data volumes, base path underscore, a data backup this is the path. So data volumes is this one. So it has displayed as what is the path for it. Okay. So now let's go and see if you have HDB data. So this is the path we are interested in now, data volumes. Okay. So let's open this. Oh, we are already there. Let me go to I don't want this Sybase system now. So this is what I'm interested in. So let's clear it. So this is the home directory, HANA DB. Okay. So CD glow. So in general, when you just give df minus kh, right? These guys have done different configurations. So here itself, you see HANA/data, HANA/log. Separate mount points they will give. Okay. So as I told, separate mount points.
What sets ZaranTech apart in SAP corporate training? It's our unique blend of expertise and innovation. We offer customized courses tailored to each client's needs, ensuring relevant, targeted learning. Our vast trainer database brings you wisdom from the best in the field. Need resources? Access our extensive training material repository anytime. We are all about measurable results, providing detailed student metrics to track progress. And we don't just teach, we build community. Join our thriving social media network, connecting learners beyond boundaries. With ZaranTech, you are not just training, you are transforming your SAP expertise.
So each one has a separate disk, and that will be defined in the data volumes path and log volumes path. But in general, that is how the standard architecture. But these guys have done, for cost saving. So they just use because it's a training system, they just use normal, but it doesn't matter. So CD, HDB. So because the parameter, so it's always good to check if you don't know where to check it. Check the data volumes. Yeah. Here you see data So here you see the data and log. So go to CD data. Okay, you see MND underscore 001 minus. Okay, you see you have this 001, 003. So let's go inside. Let's see. CD. Yeah. So you see here, do not touch in this directory. So you get the same message when you do the data volume or log volume. So PWD, let's give. So what does it mean? So your index server, whatever the data changes or anything in the RAM, will write it to this directory. Let me do a clear again. ls minus LTR. So every 5 minutes, the data changes from the RAM will be written to this particular file, data volume.dat, or in this directory, HDB003 or HDDB1. Okay, or you can call it as MND001. Okay, so you see the name itself, data. So that is how your persistency is assured. Okay, even though your RAM crashes or your RAM corrupted, you still have data available persistently on the data disks. Okay, this is more safer. Okay, and the next level is taking the backup of this. That is the second level. I mean, from the server, you are copying to the third-party location and extra level of backup mechanism. So this is how you ensure that we will talk when backups comes. But for now, you understand, right? From memory, every 5 minutes, there is a save point, index server triggers. It copies the data from memory to this directory, so that in case of power failures or anything, it is still available on the server. Any questions, guys, on this topic now? Is this clear now? Clear? Understood? Hello? Can somebody respond before I move?
Yeah, Nish.
Good. So that is how your data. We will again revisit this topic. But for now, you understand this. So shadow paging concept, what it is meaning. So this one is not so important, but again, let's look at it. Follow the diagram. So there is a page. I mean, again, it writes to the disk. I mean, the disk which I've shown you from the memory, the save point, every 5 minutes. So this is a save point, write load. So you see at the bottom, write load. So there is a graph, save point like this. So this will come. So let's say this is the save point. I mean, when it is copying from RAM to here. So it will do the concept of copying from the memory to the HANA database or the disks happens using these pages. That's the technical term. So what happens is, so change of page 4711. Okay, one particular page. It is, I mean, the content or the delta merge it is doing. And then at the save point, it will create a copy of it. Okay, so which means this page is being copied and there is two versions of one particular page is there. I mean, it is just to save. If there is anything happen when it is copying, there is a problem, it still have to have. Okay, that is why it creates this red color highlighted extra page until it says that it is completely saved in the save point. Okay, completely saved in the disk, that 4711 or that thing, until it gets saved. I mean, just before it, just a milliseconds of time. But however, who knows? At that milliseconds of time, there is a 1 crore of invoices getting processed. And at that particular time, when it is writing to the disk, it got failed. Okay, then we will be in trouble. That is why to save that, it's an extra mechanism. It will create that particular page or the small block it is writing, an extra copy, even in case at the time before the commit of the save point, if there is a failure, it still have a backup thing. That is what it is trying to say. Okay, this is the shadow paging concept. So you can, I mean, there will be a question in the certification. How does SAP HANA ensures in case of power failures to lose a fraction of the data when it is when there is a save point before committing? Before committing the save point commit, if there is a power failure, how does SAP HANA ensures that the data consistency or the availability. So by following the shadow paging concept. So you can say that, hey, these are all things copying backup and all these all can cause to performance latencies, right? Why performance instances? I told you, your database operations are all taken care by the RAM. So this is where this is happening from RAM to the data disk, right? It is asynchronous. I mean, it has nothing to do with database operations. So your application is reading from the RAM and it is excellently working and performance is good. Everything is fine. So this is a separate process. It is running from RAM to the database. So there's no impact at all performance-wise. That is why it is very good architecture, I would say. Okay, so your disk writing to your disks or IO is not at all relevant or for your system's performance. So your system performance is completely dependent on the RAM. So that is what it means. Asynchronous IO, you see in the screen. Asynchronous IO, and this is happening from your RAM and to the disk. Okay, good. So just know that there is a shadow paging concept. Before it comes to the save point, it just creates an extra copy. Once that is written to the block, then this will delete the extra copy. That's it. Okay, good. Restart process. So this is important, guys. You need to understand. So in-memory computing is secure. Let's say, how do I start this one? Good. So save point diagram is fine. You look at the diagram for now. Save point, data and undo log is written to disk. So this is the data area. Number 2, continuously and after each commit, read log is written to disk. It's a log area. Log area we will discuss. And there is a power failure. So, okay, there is a power failure here. First, let's keep this information now. So once a power failure happens or the server crashes, what is going to happen when you start it? So the SAP in-memory database holds the bulk of its data in memory for maximum performance. This I've told you. So the HANA is an in-memory. Everything is in RAM. Okay, all the data. That is what it says. But still uses persistent storage to provide a fallback in case of failure. So this is the slide which I'm referring. In case of failure, what happens? The log is capturing all the changes by database functions, which is redo logs, you call it as. Okay. So after a so the log is also saved to the disk continuously and asynchronously after each commit of a database transaction. Okay. So, I mean, this keep aside. So I've explained you the data backup every 5 minutes, save point will copy. So let's say the time now is 11:01. Okay. We are at this 11:00, there is a save point. Okay. So at this yellow 1. So until this, you have the data in the server, I mean, data disks. Okay. So this is the 5 minutes gap. So, and then at the not 5 minutes. So this is the first minute, second minute, third minute. So at the fourth minute, there is a power failure. Sorry, power failure. So what happens? It takes the data from this first save point, which is 11 o'clock. And then this 3 minutes of changes, it takes from the read log and then it starts the system. Okay. So it takes those changes and it ensures that your memory is completely refilled again. Okay. Yeah. However, it takes time, sometimes 5 to 10 minutes to touch the database. But this is how it ensures that there is a persistency always existed in the server. Okay. Good. So that is in case of power failure. So start off SAP HANA database. Okay. So now the most important and the powerful question which I will ask you is, my database is of the size 2 terabytes. Okay. You have in the disks 2 terabytes of data. So everything is in the RAM. Okay. It is very interesting and very nice to say that everything is in RAM. So imagine if your phone is just a 4 GB RAM mobile phone, if you just restart it, it just takes some 2 to 3 minutes, right? Because it has to fill your RAM with the data. So then how does this 2 TB of data from the disk will be populated to the memory? Did you get my question? Then start has to take around 1 hour or 2 hours, HANA DB starting. So if database start itself takes 1 hour, then gone case. then people will say that, hey, HANA, thank you, bye-bye. Okay. So stopping may be faster, but starting itself, if it takes 1 or 2 hours, because you are saying that everything is in memory, then your in-memory has to be populated with the data, right? I mean, when you start the system. So, and then it is not ideal to copy the entire 2 TB of data. I mean, from the disk to the RAM. So you getting my question, guys? Hello? Did you get my question?
Yeah.
How does HANA starts faster? Because in memory, if as long as the HANA is running, in memory is faster. But when you're starting, you have to get all that persistent data from your disks to populate to the RAM. Who will populate it during the starting process only? But that does take a lot of time, right? I mean, it may take some 2 hours, 3 hours to populate 2 TB of database. So then this is the another problem with in-memory. Okay. How do you ensure that your starting is quicker? So that is why HANA start is even now, HANA stopping and starting takes longer time. Very, very important interview question and certification question also. Why does your HANA takes time to start? You know, sometimes 5 to 10 minutes, sometimes BW 15 minutes. Why? Why does HANA takes a long time? Because it has to populate the data from your disks or the persistent layer to the memory, in memory, to the RAM. That is why your HANA starting is slow. You got the question? So it's a very, because unless you understand the concept which I've explained to this RAM concept, you won't be able to answer this question. So this is the thing. So whenever you start anything, your memory has to be filled. RAM, it's a fly memory. So it has to get the data and filled. That is why your starting is slow in HANA compared to Oracle or Sybase or any other database. Okay. So that is why HANA takes time to start. But yeah, still fine, 5 to 10 minutes is tolerable. But if it takes hours and hours, it's not problem. That is why it is important for you to understand start of HANA database. Okay. State of database of. So to address this problem, instead of loading all the tables, as soon as you start the database, HANA start, so during that phase, it only starts essential tables loaded into the RAM. Okay, not all the tables. Okay, keep this in mind. So they may ask you a question. So does HANA start takes care of loading all the persistence tables to the HANA memory? No. If that is the case, HANA starting takes 2 TB of database. It takes 3 to 4 hours. No, it will only copy, load to the memory or the RAM essential tables only. Okay, so loading of data from storage to RAM. This is what I mean. So this slide, loading of the data from storage to RAM. So optimized for a fast start of system. The HANA is optimized that way. So at first, query execution on a given set of data, partial loading of tables into the main memory. So data being read from save point and transaction log. From now on, only access to data in memory. Okay. So this is the thing. This is the most important logic you have to understand. So they're very smart way they designed it. So what happens? The RAM slide, I can take it for your example. Let me go back. This is important for you to understand, guys. We take this slide. We take this slide. Good. So imagine this memory. So everything is in memory. So when you just started, 2 TB of data is in memory, and these are the storage disks have the data. So fine. So what happened is you started the system. The system has been stopped and started. So the moment you started, so it won't take the entire 2 TB of database from your storage disks. Okay. So what it will do is only the essentials tables, structures, and certain tables, what is needed to run the database, it will copy to the in-memory. Okay. And then asynchronously, so I told you the copy from memory to the disks asynchronously. So the system is up, database is started, application is up and running fine. So asynchronously, it will start loading these tables from the disks to this one. Okay. So it means, so the end users, if he immediately needs something from the database, yes, that query will be diverted to the database. So even though there is no other queries are running, so the performance will be better. But after 5 to 10 minutes, So backend, the database will ensure that all the tables will be loaded to this one. That is how they optimize the start. Okay. And it will take the state of the last 5 minutes save point. And as I said, the 3 minutes, it will read from the logs and it will load to the in-memory. Okay, got it? So this is how the starting is quicker. So which means when you start the database, it won't take all the, where are we? Yes. So it won't take all the tables. It won't load all the tables. Only it loads the essential tables. Then later asynchronously, it will take care of the filling of the RAM. Okay, loading the tables. Okay, so startup process. So this is what I mean. So row storage loaded completely into memory during the startup and has to stay there certainly during the load. So again, I told you two varieties of tables in the system, row store and column store. Row stores immediately loads to the memory. Okay, so that is the reason is if somebody wants to write, insert, delete, that operation definitely needs a certain thing. But these select queries may not happen immediately. So column store tables are lazy. Okay, let's say you started the HANA database. So immediately writing and deletion inserts, row stores already populated. If somebody tries to search, select star from so-and-so TCS table or my student's data, so then it starts loading the table. You understand? That is what is meant by lazy. So whenever somebody initiates or some job will try to fetch some table, then only it starts loading that particular table. But again, guys, this is after the immediate start behavior. Okay. But after 5 minutes or 10 minutes, you obviously have all your column and roster based, everything has been copied to the in-memory. So this behavior is immediately when you start the system. So your system is started quickly, row stores are available, column stores are lazy mode. I mean, as soon as you call, they will be loaded. But after 5 to 10 minutes, everything will be available, that your database will be faster. Okay. So is that concept clear, guys? So starting. So when you start the database, what happens? It loads the tables from this row stores tables from your persistent layer data disk to the in-memory. Column stores behaves as a lazy. I mean, whenever somebody tries to call in that particular time, it loads. Or after 5 to 10 minutes, it will try to sync or it will try to load all the data disk tables and everything to the in-memory. Okay, good. So this is the SAP HANA memory pool. These concepts I will explain in this slide. Okay, this is a good slide where anyway we are going to discuss. Okay, so memory consumption. So you have the RAM. Okay, so just try to understand the. So here, only thing you need to understand is how this memory has been used. Let's take this slide. So in the y-axis, you have the gigabytes of memory. Suppose gigabytes of memory. In the x-axis, you have the x-axis, you have the usage of the memory over the time. So at the bottom, you see HANA code and stack. So for the HANA code and the stack to run, it needs minimum RAM. So here, when we say memory, guys, RAM, just keep it in mind. So we are not talking about disk size and all these things. We are talking only memory means wherever there is a term in memory, it's a RAM we are talking. So HANA code and stack to run the just HANA software, it needs some basic memory, which is gigabytes. Suppose let's say 1 GB it needs. And then to deal with all these tables, it needs some memory. I mean, to load, read, write, and select thing. So that memory slowly it is increasing. I mean, whatever to load the latest. So after some time, sometimes what happens is there will be a peak load on the server. I mean, it needs a lot of memory. I mean, somebody has triggered a BW report. So immediately the memory gets spiked over here. You see these spikes. So which means, so used memory high watermark. So it means sometimes it goes to the peak. So at that particular memory time, so system might not have enough memory. Okay. So then what it will do? It will try to take the memory. So here you see the physical memory. So the top line. So the top line is, let's say the 2 TB is your RAM of your server. Like you have mobile 4 GB phone, right? So 2 TB is your physical memory. So what it will say is you have an allocation limit you can set. So generally in HANA, 90% of the RAM is allocated for HANA only, 90%. Okay, which means if your 2 TB means 1.9 TB of will be allocated to HANA. That is what is mean by the allocation limit. So it will go up to allocation limit 1.9 TB. Okay. Even after that also you can define, you use this 10, the remaining also. So it can go up to physical memory. This is what it is meaning. Okay. So this virtual memory, resident memory, just you keep it for theoretical purposes. So I mean, what it means is when you cross it, so it just crossed the resident memory, they call that word, in those peaks. I mean, the remaining memory, whatever is available. Okay. So this virtual memory is nothing but the peaks, how they are going. So don't worry, these are not the actual things. But physical memory is important, 2 TB, and allocation limit is important. I mean, how much you have fis mem size. There is a parameter called fis_mem size on the HANA, we can check it. So how much is the allocation? And then you have these spikes. So the HANA can use up to this physical memory, 2 TB maximum, or the allocation limit. Okay. So what it means is, even if the allocation limit is reached, HANA tries to consume the physical memory up to 2 TB. I mean, the OS memory also. Okay. That is why it is an in-memory. So it uses every RAM available, and all the RAM, whatever is allocated for the server, it can go up to that particular RAM. But if you see such spikes, right, I mean, it is reaching to the physical memory and all. So then you have to decide it is the time for you to increase the RAM. So let's see what I'm trying to, sorry. Let me close this. Let me see, show you. Oh, so not in this one. No, HANA database. Okay. So landscape or in performance. Performance, do you see something? No. Overview. Can you see this, guys? SAP HANA used memory. Memory, peak used memory, allocation limit. So you see, used 34.05, peak is 36.45. Okay. So what it means, where do we go? Okay. So peak memory. So this is the peak in this case, in our diagram. This is the peak. So how do we call it? Let me close this. Okay. So the peak usage is, so you put the cursor here, peak 36.45 is the peak percentage, and used is currently used is 34. But this system has how much? 92 RAM. So which means only around 40% of your memory is being used. So which means still the server is good to say state. Suppose if this goes up to 92, which means it is consuming all the physical memory, whatever is available. Okay, 90 GB. Then it's a indication that you increase the RAM. Okay, increasing the RAM, two options: scale up and scale out. Scale up means increase the RAM by the same server. If that is not possible, add one more server, one more node. Okay. So database resident memory on host. I mean, so far how much peaks and all considering, it will just tell you that maximum 50.52 has been consumed. Okay. I mean, with the history of the data, that is why it says resident memory is so and so. Okay. Let's do this thing. Memory is, yes, that is how your HANA will work with this one. This is important indicator. And then you click on the landscape. So here also, it's also a clear indication. Index server. So this CPU and then memory. So if this goes, yeah, you see here memory values. Service used memory 29 GB. Service peak use 30 GB. Effective allocation limit 90 GB has been allocated for this one. So that is what I am trying to say, allocated. So physical memory, how much? So 100 GB. Clear, guys? Can you see? So in this diagram, so try to make this one. Physical memory is 100 GB. Okay, bottom one, 100 GB. Allocation limit is 90 GB. I told you, as per normal, 90 GB is the allocation limit. 90% we will allocate for HANA. So remaining 10% is for your 10% is for the operating system. Okay. So and then service peak is the 30 GB. Service used is fine, but which means your system can use up to this 90 GB of memory, which means your system is at the better shape. Okay, so good that you understand. So the next important thing is storage and memory management. So the same thing again I have to explain. I mean, from the memory to writing it to the data. Okay, main memory, you have this RAM. Okay, whenever it writes to the database or the persistence disk we are talking, it will do delta merging. I told you. So it won't copy the everything from RAM to the database. Delta merging. What is the meaning of delta merging? So here it is the delta. So these all concepts I've explained you guys already. So from main memory, for read operations, everything will be available. For write operations, only the delta values will be returned to the database thing. Okay. But when it is writing this thing, it will take care of the data compression in the main storage. Compression in the sense like zipping or RAR, what in our normal terminology is what we do. Such kind of compression, it takes care of it. Okay. There will be architectures for the compression also. That is not irrelevant for us. So which will reduce the size of the files and place it in the system. So let's say compression means nothing, guys. So what in the table space, you have a table. Okay. In the table, some inserts and deletions happen. Okay. But still that rows will be available, right? So you have a table, a 4x4 column table. Some fields have been deleted. So still the table is there, but those fields are still existing. So when it is writing to the disk, okay, persistent disk, it will take care of cleaning up those fields. It will compress the data. So that is how you save some time, some space. Okay, that is the actually compression. Okay, so now merging. How does it merges to the data? So this is also very simple. If you go with the diagram, it may look so complicated. For example, main one data area in the memory. Okay, delta merge changes in the column store. Let's do this one. So reading, so you are reading it, and delta merge operations. Main one will take a copy of the main two. Okay, and then it will write the delta one to the changes to the delta two. Okay. So main one is being written to the main two because one copy of what you are trying to change. And then the delta changes also delta one to delta two, and the changes will be written to the delta two. And while you are reading, your main two will be read, and those changes will be written to the delta two. Okay. So, what I have to, how did I put this one? This diagram is not so good. This diagram only much better to explain this thing. Good. So you have this main memory RAM. Okay. So main memory, and you have this delta. So when you are writing to your database, right, only this delta changes. Okay. So what that other diagram will tell you is, so this main, it will create one copy main 2, and this delta also, it will create one delta 2. While it is merging to the data store data. So data persistent layer. Okay. So it will keep 2 copies of this. 2 copies. That is what paging concept I've explained, right? It always have this one. So once that is written to it, once that is written to the data disk, so then these new files will be read, main 2 and the delta 2, whatever the new state one. Okay. That is how this will write it to from memory to the database. But anyway, these things are not visible, or we don't see it with eyes in the system for us, but you just try to have this is how it will do the writing to the database. Okay. So, but now the most important thing is our topic, SAP HANA start. Okay. So how do you stop and start the database? Okay. Let's recap it before we proceed, guys. What we have discussed, SAP HANA architecture, in memory, okay, copying it to the data, and in memory, how in memory it runs. In case of system restart, what happens? It has to load the tables from the disks to the latest, to the RAM, but it won't load all the tables. Only row store or their essential tables it will load. Columns tables behave for lazy. Whenever somebody calls to try to access, then it will call it. And after that, after some time, it will load all the tables. That is how your in-memory computing works. Okay. So, and for the persistency purpose, every 5 minutes from the RAM, the index server copies the data to your disks every 5 minutes. That is called a save point. and every fraction of second, whatever the changes in the happening in the system, it will be written to the database, what we call as a logs, redo logs on the server level. Okay, is that clear so far? Now we proceed with stopping and starting of the actual things what you do. The rest all are like theoretical or the concepts which you have to have understanding. I mean, whether you like it or whether you understand it or don't understand it, but over the period of time, you have to get comfortable with these topics. Okay, so maybe it is the first time you are getting to know these topics. You may feel too much tough or too much complicated, but over a period of time, when you started working on these SAP systems, right? So maybe 6 months or 1 year, 2 years experience you gain, definitely you will be able to relate these topics. Okay, every 6 months keep checking this PPT. So that is the best way. Every 6 months open this PPT and then have a look at it, just over a glance. Then you will be able to connect, okay, with your experience and with your tables and structures. Then you will have a better understanding of the concepts what I have explained you. Is that clear, guys? Shall we proceed further? Now let's proceed with the HANA stop. Somebody is saying something. HANA stop, and then we will take these slides I already explained, so this doesn't take much time. Good. So we have few. Good. So let's try to stop and start the database. We'll see if we. Okay. So let's try to stop and start the database today. Good. So starting and stopping of the SAP HANA database. So there are 2 ways to do it. 3 ways total. Number 1, HANA Studio. And number 2, stop and start using HDB command. Number 3, SAP control, the way we do for the application, right? So I've shown you how SAP can be stopped, SAP control. So HANA, you can do any of these things. So the easiest is to go with the HANA Studio. Okay, let's go to the next slide. So HANA Studio, if you want to stop something, so you see here configuration and monitoring. So start time, wait, and the SID ADM you have to give. Let's go there. Then you will feel easily. See, this is the system. So these are the index server and everything running. So if you want to stop configuration and monitoring, so please focus on this. And one more thing, if you has anyone worked on any other database? Oracle or Sybase or any database? Does anyone has any experience? Okay.
Not working experience, but SQL and MongoDB have done.
Okay, fine. So in Oracle starting, I don't know if recently, it's been 5 years. I was one of the Oracle expert when HANA 11.0, HANA 12 was there. Okay. In my earlier projects I used to work, but last 5 to 6 years, I never worked on the Oracle. So, but the difference is, I don't know if you guys have any studio like this in Oracle. Very recently, have they provided any studio?
Yeah, they have provided.
Okay. So when I was working on HANA, on Oracle, we didn't have this studio, okay, or Oracle Cockpit or whatever it is. Okay. When the HANA 11 and at that time. So we always had to go to the server level and then execute SQL commands to see the statuses and stuff and the logs. Okay. So that time, initially we felt bad. But once we become customized with those commands and all right, we felt so good. It's like intellectuals, like people who knows it, right? They read Hindu newspaper, and there's a difference between reading Hindu newspaper and Times of India. So the people who reads language more and who want some new words, they like Hindu newspaper because content is so strong in the sense, same content Times of India also explains, but Hindu newspaper, they use jargons and critical words and they make it complicated. So like that, when we were working in Oracle, we had that so much satisfaction that we are executing OS commands and then we are seeing everything and you feel like, and nobody else can do that. But when HANA was introduced, so what I'm telling is, they made it so simple. You don't need to be a basis guy. So that is why we didn't like it. It's a dissatisfaction for us. But if SAP introduced this HANA, then why do they need basis guys? Everything is so simple. I mean, any L1 guy or admin guy, fresher can do this. I mean, without having any knowledge, if I ask you to stop the system, whatever I've explained in this last 2 hours, you don't need any of that knowledge. Okay? I mean, for doing many things I'm telling you, for just executing, you don't need any of that knowledge. You come here, configuration, stop system. That's it, matter settled. Okay? So here, it will ask you whether you want to do a soft shutdown or hard shutdown. So since you are working on the Oracle, so you have in Oracle also force, I think, I don't know if they changed something now. So force, immediate. So that is also there, right? Immediate shutdown. Shutdown, immediate. Shutdown, force.
Show immediate.
Sorry?
Shutdown immediate. The shutdown immediate.
Shutdown immediate. Shutdown abort, I think there is one more option, right? So
yeah,
what is the difference between shutdown immediate and shutdown abort? Or shutdown soft, I don't know, there is one more, I don't recollect it, sorry for that. But there are options. So what do they mean? So now here you see, they just renamed different terminology for it. What is the soft and hard? It explains here only. So it stops the system. All currently running statements are stopped. After the specified timeout, the system is hard stopped. Okay, this is what is mean. So which means if there is any job which is running, okay, if there is somebody is trying to do something, it will let that particular thing to complete. And it is useless. You don't know. It may take some half an hour, 1 hour, or 2 hours. Okay. But there is a timeout which we will set. We just wait for 15 minutes. I mean, just see 15 minutes. If those transactions completes, then you stop it, hard shutdown. If not, I mean, if it is not complete in next 15 minutes, it will stop. That is the meaning of it. Soft means it will ensure that the currently running transactions will complete till up to a certain timeout. Okay. Once the timeout is reached, it will go with shutdown. So in general, we do stops the system immediately. It is like shutdown immediate, like Oracle you do. Shutdown immediate, which means open transactions are aborted and rolled back. Okay, which means whatever somebody is trying to do in the system, so they will say that it rolled back. That middle of the transaction has to commit in this database. So whatever it is in the uncommitted transactions, it will roll back. I mean, to the state where they have initiated it. Okay, so that is what is the meaning of the hard. And let's say hard. Okay, what it gives. So for this, so see, this is so simple. I mean, that is why we didn't like it initially. Our intellectual ego was stopping us from liking HANA. But later point in time, when we looked into the architecture and all, we felt good. But initially, many of the basis SMEs or the architects, it's not because of HANA is bad. There is a negative trend. I don't know if it's still there or not in your company. Seniors, you ask, because their intellectual ego or whatever it is, it gets hurt when you are working on HANA. Because these guys have made it so simple. Any L1 or anybody you see, for this, who else needed? So there itself, it explained what is soft and hard. At least in Oracle, you have to go to the OS level and execute that command, right? That feel you have. Linux, I'm logging in, I'm doing that. So people don't like this. So because of this reason, oversimplification. So then you come here and give the SID ADM. So in this case, HDB ADM, then password, that's it. Click OK, stop the system. It will stop it. Let's not stop it. So this screen, it is the meaning. So then it will take care of, or at the end of the session, we'll do it. Okay, because I want to continue some other things. If it stops and it won't come up, then it will be a problem. Because it's a training system. So after you stop it, it will take all these processes, looks bad. It looks into the red color or a gray color. Okay, is this clear? It is so simple, guys. HANA stopping and starting. Or there is another way. If you don't like this thing, this is such a simple way. There is a simple one more way. So go there, just go to the CD, home directory. So see here, okay, CD, CD dot. Let me exit. So su-hdb ADM. So as soon as you log in, you will be in the instance directory. So this is the instance, HANA, like application instance, you have a HDB instance directory. So just give ls-ldr. So there is a program, HDB. Okay, HDB. So if you give info, it will give information about it. What process is running and all. So our HDB version, it will give the version of the HDB, what you are using. It's a program. Okay. So if you give HDB, stop. it will stop. Okay, Control C. So HDB start. So simple again. So no SAP control, nothing. Okay, if you just give it, it starts. So it's so simple. So that is how you stop. Oh, sorry. You stop and start the database. It's as simple as that. And the third way is the typical way which I explained, SAP control minus, here is this diagram. SAP control minus NR function stop. This we used it already. If you want to see the, we can see the SAP control minus NR function get process list, like any application. That way also, SAP control minus NR minus, what is the instance number here? 00. So I told you it's an instance directory, 00. Okay, you see this 00. You can pick it. Generally 02 people use, but whoever has built it, he used it 00. Okay, generally for a HANA, people use 02. Okay, so minus function. So basically, it also shows HDB info related only. Minus function. So get process list. You see, same like daemon is running, compile server is running, index server is running. See green, this one. Name server is running. So it is like HDB info only. Okay. So starting and stopping, again, there is an important question in certification. Pakka they will ask you. One question guaranteed here. How many ways you can stop HDB, start and stop the HANA? Number one, from studio, option is right. Number two, using HDB program at the instance directory, yes. Number three, OS level. Command line tools. You can call it as a command line tools. OS command line tools. Okay, that is nothing but HDB, the one which I've shown you. HDB info, HDB version. And the third one is SAP control. Okay. So this is an important question. So total 3 ways you can start and stop the HANA. So these are the 3. Okay. But again, here also you have to, so this also documented. So I don't think anything I have to tell you here. Simple commands are given over here. Okay. So then this is also an important topic, guys. Let's see how do we take the backup and logs. Okay, let's take a backup. Then we will be the concept of backup recovery, estimate the size of backup. These are also, so these things we discussed. So log backups, that's fine. So these are all, we have discussed it. So what it means is persistence and all. So data, how from the memory, let me recap it before we go for the backup. So we have this, look at the diagram. From memory, data backup writes to the data volumes. So regular automatic save points. Every 5 minutes, it takes the delta margin or the delta data and writes to the data volumes. Okay. And then log volume. So whatever the changes happening now, every fraction of second, those will be synchronously written to the log volumes. Okay. That is the thing. So where do you see the log volumes? Let's go and see. Where do you see the log volumes and data volumes? So there is a parameter in the system. So configuration. So let's see the performance. So data volumes are in HDB and data. Okay, let's do CD glow. Oh, we are on the same server. So CD clear, CD glow, CD HDB. Yeah. So here you see both two directories, ls minus LDR, data and log. Let's do this. So ls minus LD. Let's do the LD, data and log. Let's check these two directories. Okay. So in this directory, I don't want to display everything available. So in this path, you have data and log. This is what is defined in the parameter also. Okay. Your data is being data volumes. And then if you put the log, or let's open the entire persistence. We will discuss about it. Persistence. Index server persistence. Yes. So this is the global.ini. Persistence is important. So log volume is a log backup, where your backup go. If you trigger a log backup, data backup will go to this directory. But for now, that's not a worry. Data volumes we have seen. Log volumes This is the logs, redo logs. Whatever the changes happening in the RAM now, every fraction of second, these will be copied to the log directory. And we are in the same server. Do this one, CD. Let's go and see the logs. Okay, CD, MNT. Okay, see this one, CD again, if you want to see. Yeah, see log segment 00 logs, read logs. These are called the read. Do not touch these files. So never ever touch these files, guys. Okay, so the reason is if you delete them, then you lose the data. Suppose if there is a power failure, I mean, if the system crashes when you delete it, then you don't have the changes recorded anywhere. Okay, it's very, very important. Do not touch these files or these data files. Okay, clear? So data persistency we discussed. I mean, from your memory to the data, it always writes to the disks. So which directory it is? CD, USR, SAP, HDB, same directory. So data. So this directory, it writes to this MNT001, it writes the data files. So it has the log segment naming and all. So we discussed in detail about the data, but there are some more important things you need to understand about these logs. Okay, how these log segments are written. Let's come to discuss that and then we come back. So let's discuss and come back. Okay, overview of backup and recovery. So you have in a HANA Studio, okay, SAP HANA database, and you have the persistence layer, data volumes and logs, which I've just shown you, these two directories. Okay, so this USR SAP log directory, USR SAP data directory. Okay, from the memory, index server and these writes to these layers, data volumes, the data, and the logs in a synchronous way, it keeps on writing the changes, whatever is happening over here. External media, this you need to understand. Why do you need, I told you I will explain, why do you need to take the backup of this data volume and these logs to the external media? Can somebody explain? That is what is the backup. So backup, this is not the backup, writing to the persistence layer. This is nothing but from your memory, I mean, in memory, it is copying because it's an in-memory database, copying the changes to ensure that persistent in the data volume and logs, so that in case of a server crash, it can immediately know the status of your database and it can start. Okay, but why do you need this external media backup? Why do you have to copy? So see, this HDB data and these logs, why do you need to copy to the external media? Can somebody explain? This is the one of these. Archiving for what? Archiving
is when like continuously when we write the data on the database, like at some time it will be like database will be filled. So it on regular basis, like older than some time period. So we need to archive those data into the external tapes or something.
Okay, that is good example. Yes, you do have to have your state of your database in the archive. But I told you, for example, if you are doing an upgrade, right? When we are talking about an upgrade, before you do proceed with an upgrade, you have to take the backup of the system, right? What do I mean the backup of the system? So this data and log files backup, okay, to an external media. So for example, you are upgrading this SAP application, which means the changes will be written to this data volumes and logs. Suppose if you want to revert to the state, before the upgrade, so then you have to go to the backup before you have taken. You getting my point? So backups is very, 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 very important. For every basis activity, backup is the first and foremost requirement. Believe me, you just make it as a very clean thing. So in DB13, you have these backup monitors, right? Wherever you go and check it, every activity you need to have a backup in the external media or wherever, in a separate location. So this external media, so it can be locally also, you can save the backup, or you can save it to this different server or a NAS filer, or you can send it to the external media. It doesn't matter. Wherever you want to store their data, backup. So it is just like taking the copy of your data and logs before you are proceeding with any of the activity. For example, transports. You are importing the transports to the system. It makes changes to the data and log, right? So then you need to have the backup. So because if the transport fails, you can revert the system to your previous state, point in time recovery. Okay. For example, upgrade, you need to have a backup. For every activity you do in Basis, most of the activities, node implementation, yes, you need to have a backup. What is your remediation plan? I told you, every planned activity, you need to have a backup. I mean, how do you remediate? How do you, if your activity plan fails, how do you come back? So most of the activities are critical. Whenever there is a change in the database or something writes in the database, if you think, so, better to you check the backup is available or not latest. So that is why backup is one of the most important basis admin task for a basis guy. So you should know how to take a backup. You should know how to recover the system. I mean, in case of if you want to revert it 1 day before or 2 days before or the point in time recovery, I mean, people will tell you that I want to a state of so and so time. That you need to know. That is only possible provided you have the backup, okay, of your system. Okay, so that is the significance of the backup. So this is the distributed HANA landscape. So same concept. So irrespective of your host 1, host 2, host 3, whatever hosts are there, so everything goes to the data disk and everything. So the backup concept remains the same. This is what it tries to say. Now, overview. So data backups, external backup destination, log backups, again, external backup destination, most recent log entries from the log area. Okay. So this is called the point in time recovery. Okay. Let's talk about this one. So for example, we have the EH8 system. Okay. The system which we are using for our training. Please connect it, guys. Please try to understand this business case. EH8 system. We are proceeding to upgrade the system. Okay. What I did, I took a backup of data backup of the system. Okay. So this is what the point 1, data backup. So data backup, immediately I triggered, half an hour it completed, and those files, it doesn't matter where they copied. It's an external backup destination or in the same server. If I have a space, I will put it over there.
Our comprehensive student metrics ensure top-notch learning experiences. We track engagement through attendance, participation, and video interactions. Performance is measured via quiz scores and assignment submissions. We monitor learning behaviors, including time spent and revisit patterns. Our metrics cover social learning, course completion rates, and even post-course success. With technical data on platform usage and device information, we optimize every aspect of your learning journey.
But I ensure that there is a backup. Log backups also same. I have taken to this particular time and I've kept it. So let's say that if you have done the upgrade of the EH8 system, and after in the middle of the EH8 upgrade system, you have realized that, oh, my activity has been failed. Okay. So then you want to revert it to the, what is the time now? 11:48. So you want to revert the system to the 11:48. Okay. Which is now, 11:48. After 3 hours, at 1 o'clock, you realize that you have to revert. What it will do? You have to restore this data backup first. Okay. The backup you have taken. So it could be 11:48 or whatever it is. And you have to restore these logs also to the server. And then you initiate a recovery. Okay. Restore and recover. Restore means getting those files from the tape or the files or whatever to the server. That is a restore. And then recover. So the recovery also, there are times. So when you do a recovery, it will ask you till what time you want to recover. So you mention the timing. So it will read these log backups. What I did, I tell you, logs will contain the changes, time to time. So if you don't have these log backups, okay, then you can only restore to the system up to this point, data backup. Okay, whenever the data backup has happened. So please ensure that you have both the backups, because data backup, there is a chance of losing data because the changes doesn't come. The fraction of seconds or whatever the minutes. So if you want to have an exact point in time recovery, 11:49:00 seconds or 01 seconds, you need to have the log backups. So get these two files from your tape or whatever the location, and then you recover and you mention the timing, it happens. Okay. This is the point in time recovery. So what are the overview of the backup and recovery capabilities? Okay. So it's just theory. So data backup possible, storage snapshot possible, log backup possible. So backup and configuration files, no. So what all things in the backup can happen? So point in time recovery, it is possible. recover for a specific data backup. I told you, if you take a database backup, only to that database time it is possible. So life cycle management, integration of the backup. So these are all things are possible. So just keep it aside. So now points to note. For taking the data backup, okay, I mean data backup means I am talking about these disk data volumes. Do you need to have the system to be online or offline? Tell me. It's online only. Okay. It is again a very, very important certification question, guys. So in Oracle and in DB2 or in other databases, you do have an option of offline backup. Do you agree? The guys who are working on Oracle. So you have an offline. Yes, you do have an option of taking an offline backup, but this HANA data backup is only available in operational mode online, which means the system is up and running, then only you will be able to take the online backup. Okay, good. So they will ask you this question. In HANA, you can take backup in offline data backup. They'll specifically mention HANA database backup can be taken. I mean, when I was writing, it came offline also. So it doesn't work. Offline, no. For true or false question, false. Okay. So during data backup, the system is available as usual. Okay. So you may ask, hey, you are running a backup. Does it impact my performance? Can it impact the performance? Can somebody tell me?
Practically, it should affect the performance as the system is online.
So now then we have to review our architecture, what we discussed. Okay. So you see this slide. So first of all, writing to the data and logs itself has no impact on performance in HANA. So, okay, let's look at it. So HANA Studio is a front-end device, forget about it. So HANA database, index server, name server, these things will take care of the operations where? In memory, right? I mean, RAM. So entire database is running on the RAM. I mean, the 2 DB of RAM. So persistent layer is nothing but just writing those from RAM to copying to the persistent layer, data and logs. So first of all, writing the data from that RAM itself to the persistent layer has no impact on performance because your application reads from the RAM. That's it. Their point of contact is RAM. So they are reading and writing everything in the RAM. Okay. So now we are talking about backup. So we are taking the backup of data volumes and logs. So this does not have any impact on the performance of the end users in a HANA. Okay. It is negligible. Zero. I mean, even not zero, there is no, because you are taking the backup of the bottom layer. So the end user has no interact on the database layer because they do everything on the RAM, right? You getting my point? I don't know who has answered it. Akanksha, is it you?
Yeah, I got my mistake as soon as you. I forgot that the RAM is operating. Yeah.
So this is the thing in HANA. So that is how it is different. I'm sorry, guys, I can't compare with Oracle now. I mean, I told you 4 or 5 years back I worked on it, but now you get it. So these backups, there is no impact on end user impact. The whole thing is running on RAM, and that is how SAP solved that problem. So the disk operations or the IO operations, first slide bottlenecks. So when you try to do everything on your database, then it has a bottleneck. Earlier when you run Oracle and that architecture, when you run the backup, definitely there is a performance impact. I agree with you, Akanksha. So we used to run the backups in the night time. Even if you see DB13 and all, you would have scheduled the backup in the night time on when there is a less load on the system, definitely. So that was the problem. So SAP has addressed by keeping the in-memory and keeping all these database extensive operations separated in persistent layer. They have separated those operations in a completely different way. So then they achieved this performance gain. Okay. So good. At least now you understood. So that is what I'm trying to say. During the data backup, the system is available as usual, or they would have told that there is a little, performance degradation. Now the next question. During the recovery, the database cannot be accessed by the end user and applications. Okay. Now during remove it does. Does the database can be accessed by end user during the recovery mode? This is important. So which means when you are recovering the database, so it is not accessible. Okay. So during the backup, the system is available as usual. When you are recovering it, suppose, so for 11:55 now, if you are restore and recovering the database, obviously the system has to be down. Okay. So backup supports file backups, third-party backup tools, backend. So there are so many backup tools. Okay, as I said, they have opened to all open tools. So integration they have improved. So which means backend tools like Cohesity and Activio, these are the backup solutions. So you can use, and in Oracle, I think you have BR backup, BR recovery, BR restore, right? BR tools. I don't know if you guys heard of them.
Yeah,
So BR, yes, BR tools you might be using for them. So like that in HANA, so they are open for everybody. Anybody can develop their backup solution using a backend is an architecture mechanism. I mean, it's just that they're copying the files and placing it some storage device. So it doesn't matter. So that supports. Okay. So at the beginning of a recovery, all the data and log backups to be used must be either accessible in the file system or available through the third-party backup tool. So this is the important thing. So as I told you, so if you want to restore back to the system to your previous state, you should have the backup available on the server. I mean, you have to copy them. That is what restore is. And you have to have the logs also, okay, on the server. So the configuration path for the data and log backups must be valid throughout the whole system and not only on the specific host. That you can see in the, that we have seen in the, where we have seen in HANA. Yeah, in the studio we have seen. So what they mean is these log volumes or this backup path, log backup path. In this case, they have created a backup directory and then put log. And then here data volumes, data backup. So in this parameter. So this is the path for you. Suppose if you trigger a backup, so it will go and stores the take files over here, or you can define a path where you want to copy the backup also. We'll see if we can trigger one now. Okay. So this path has to be common for all hosts. For example, you have a multi-scale out scenario, host 1, host 2, master slave scenarios. So this path has to be common on a whole host. That is what they mean to say. There is another question. But it is a stupid question. But again, for example, we have our HANA system now. So what version we are now? So let's go and check the properties. Okay. Yeah. Properties, version history or HDB version you can do. So it's a 2.052. Okay. In this case, we are doing a point in time recovery on the same system. So same system means it doesn't matter. Okay. So, I mean, it is on the same version, HANA version for sure. I mean, because only one day we didn't do any HANA software. For example, system refresh. I mean, from production to test system, you are copying. So please note that this is a very important point. So you cannot copy this system, I mean, this backup and restore it to a, because system copy means what? You do backup restore only, right? You take the production backup or any other system copy, a system backup, and then you place. So it is mandatory that it is well and good if your source and target both are at the same software version, or at least your target should not be lower version. For example, your current version is 2.0 52 patch. Okay. For example, your quality system is of 2.0 40 patch. So it do not work. Okay, that is what it means. So whenever you are doing a backup restore or building a new system, your target system must have a software version with the equal to this or a higher version. Higher version may work, but lower version downward compatibility doesn't work. Okay, that is the most important thing. I mean, when this you face it when you are copying using one system backup with another system. So ensure that your HANA software is updated to this system version. So this is a thumb rule. Ensure that even in client copies also, right? You need to have the same software component versions in the source and target. So same is the case here. Okay. But higher versions, it may work, but lower versions, definitely not. That is what I mean. SAP HANA database cannot be recovered to a SAP HANA database with a lower software version. That is what is the meaning. So these questions are very important in interviews or in certification. They will tweak it here and there and put it to very, very, very important questions. Okay. So the moment somebody can go in depth of these questions, I mean, and then, they can assess your DB skills. Okay. See, I told you, they can take, when the database is down, can you take a data backup? No, database backup only runs in HANA when it is online. Okay. During a recovery, can it take the system down? Yes, the system has to be down. Okay, how do you do a restore and recovery? First, you copy the data backup and log backup to the server, and then you initiate the restore or recovery from the studio. Okay, and then when you're doing a system refresh from production one system copy to another copy system, suppose if your target system is at a lower software version, can you do a restore recovery? No. So it will give inconsistencies. So at least it has to be equivalent, both of them. Okay, so good. So backup destinations. So as I said, it can be taken to the files or third-party backup tools you can do. So data backups are carried out manually. So SAP HANA Cockpit, SAP HANA Studio, DBA Cockpit, in the system, SQL command. These are the various tools which you use to trigger the backups. So planning and calendar in DBA Cockpit using script. So yeah, let's see first how we take the backup. Then I'll ask one interesting question. So taking backup, again, it's very simple. So our intellectual ego doesn't accept it. Those who are working on Oracle, you may feel it's so stupid and easy. So backup system, it's very simple. Just click and then backup destination. So where you want to copy the thing. So backup and data. So you see this profile in the right side. So I highlighted in blue. So backup and data. So this is the data backup. This location by default it go. And if you want to put some specific path, you can mention backup destination. You can change it. So let's take it. So the size is only 17.94 GB. So 17.94 GB. So it should be fine. It should be able to take the backup. So let's click next. So review the backup settings. So it is system HDB, BW for HANA. This is the version. Backup type, complete data backup. And then destination type, it is a file. We are just taking to the server. Backup destination, this one. And backup prefix. Prefix means the files which starts with this one. So let's do a finish. Okay. So it is taking so basically all other servers, it takes quickly, but index server may take time. Okay. So this is how you take the backup. It's as simple as this 1 minute task. For this, you don't need this training, but for troubleshooting and understanding the architecture, you need this training for sure. Now, so you see index server, it is faster. Unlike I don't know, Oracle is faster now, but unlike other databases, it is hardly 5 minutes, it will complete the backup. You see, already 33% completed. Okay. Now the question is, can you schedule the backups from HANA Studio? Can you schedule it's a certification question. True or false? Can you schedule the backups from HANA Studio? Very tricky question. Daily ones or monthly ones or this daily frequency you schedule, right? Schedule is it a triggering? Can you schedule the backup from HANA Studio? Can somebody answer yes or no? While the backup is running. So from HANA Studio, we will not be able to schedule the backups. Okay. HANA Studio, yeah, the backup has been completed. So 2 volumes were backed up. Okay. So let's do, okay, fine. Let me complete the question. So from HANA Studio, you see only the backup option. You don't see any, what we call scheduling. So the scheduling can only be done from the planning calendar, DBA Cockpit. Okay. Please remember this, guys. So data backups are carried out manually. If you want to trigger now, so you can use these tools, Cockpit, Studio, or DBA Cockpit also you can execute, or SQL commands also you can trigger. So DBA Cockpit also you can go and you can trigger immediately. But scheduling, you want to run every day or alternative days, you always have to plan it in the DBA Cockpit or use the scripts like SQL scripts and schedule them in the cron job or, at OS level. You understand? Is the question? So HANA Studio, you cannot use to schedule the backup, but you can use it to trigger the backups. Okay. So, yeah. So now there are 2 types of backups. Overview of the complete area backup. Yeah, these paths and all we discussed now. Base path _ data backup, data volumes, log backup. So this discussed. So one thing I want to discuss is full data backup. And then there is an incremental backup and differential backup. Okay. So in general, in production, so I don't see anybody recently, people are using this. Incremental and differential. So what is these differential backups is? So current complete full data backup, which we have taken now. So where is this one? Backups, let's go. So let's click on the backup. So let's click on this backup catalogs. So 21st September 1205, which I've just taken the backup. So let's click on this. Yeah. So it says successful data backup. This is 17.95 GB. Okay. So the files are available at it is a complete data backup. That is nothing but a full data backup. So, but there is a delta backup option, incremental. So for example, if I want to trigger a backup now, okay. So if I want to trigger a backup now, I already have a backup of at around, what is this time? 1201. So now the time is 1206, 5 minutes. So I have an option, incremental backup, which means only the remaining 5 minutes, I will take the backup. So it will, again, if you want to restore it, you need both the files. I mean, this backup file and then that incremental backup, whatever you scheduled. But I don't see anybody recently scheduling these backups this way. Okay. Reason? So yes, 10 years back, people were using these incremental backups, and what they do is they have every weekly twice full backup. Like I've taken complete backup weekly twice, and then remaining 2 days they have an incremental backup. So can you tell me what could be the reason why they schedule that? Cost saving. So how much they can save? Number one, complete backup means, for example, 1 TB, in this case, it's very small, forget about it. So if they have 500 GB of database, so weekly twice, they need 100 GB, 500 GB on Tuesday and 500 GB on Sunday. Remaining days, only incremental, some 20 GB, 30 GB. So in 2010 and 11, those days, the space is very costly. Okay. I mean, the hard disk spaces are very costly. Nowadays, that is the cheapest thing, whichever, in Amazon store or anywhere, 32 GB, they will give you for free in Google Drive. So, I mean, the storage is very cheaper. So as I told you in my initial sessions, so these mobile phones, they are just doing selling with the storage, right? 32 GB, 40 GB, 64 GB, Apple, and it's all marketing gimmick. So the storage is the cheapest available. Okay. So, I mean, you can use any online drives, OneDrive, Google Drive, any drives, it is free. And this disk space is also drastically reduced, very cheaper. So now you don't have to go with this incremental and decremental or the differential backups. Okay. People will go with the full backup. So they're not going to save anything much over there. And full backup means your restore recovery is much easier. So one file you have to copy, okay, or one backup. Or else incremental means you have to go with the incremental files and all of them. And in addition to that, log files also you have to copy if you want to recover the database. Okay. That is the complexity involved with this incremental and decremental differential backups. Okay. So now the next question is, okay, now we took the backup. So let's go to the server level and see if we have those files. So configuration, so backup configuration. So here you can check these guys. So what is your destination? Where, I mean, by default destination. So, and the log destination. So the left side is the data backup, right side is the log backup. So if you take the log backup, where do these goes? So let's go to this location at the server level. Let's see if we have the files to the CD. Okay, backup and data. Let me clear it. ls minus LTR. So you see, so all are these 3 files which we generated. Okay. And when you are taking backup, you better to put, this guy has put 1709-2021, right? You put such a name. So before he is providing the server to me, he took a backup, data backup. So you always put some description. So these are the September 21, these are the backup files which we have taken. Now the question comes, if I have to restore the database, how do I restore? I mean, if I have to go back to the state, I mean, to this backup state, again, it's very simple. So configuration and monitoring. So open administration, restore, backup and recovery. Can you see this, guys? Backup and recovery. So recover system. Okay. So it will ask you to give the HDB ADM password. Let's see. I'll just show you to the path. So is it connected? Where did it go? Yeah, it's refreshing status. Let's wait for some time. What happens? Hope it is not taking down the system. Yes, I think it will stop the system. Let's see this. Preparing the recovery visit. Let's wait. So you see at the bottom, so the prepare recovery visit 50%. Let's see. So it's very simple. Suppose if you have taken backup to a different copy or tapes, right? You have to get those files to the server. I mean, bring them to some location. So in the recovery, you just have to give the path location, path for those files. That's it. Your recovery is done. See how simple it is. So, I mean, they have done some simplification. So that's what our intellectual, we people may not like it. So it is getting some 66%. Let it be. So let me keep a monitor over here. So it's preparing a recovery widget, 66%. Even if it stops it, that's okay. We will cancel it later. This is how you do the recovery. So it is 83%. I just want you to show, to at least to what level. So this backup, recovery, this persistence, data, log, restore, recovery, taking the backup, irrespective of your database type, Oracle, Sybase, each one of them have these concepts, but different ways of doing it. But concepts are very same. As a basis guy, you don't have to know, how this SAP is doing recovery, you don't have to know. But what you should know is, if I want to recover my database to a certain point in time, I need my data backup and log backup, and you have to get it from the tapes. You can ask your network team or whoever it takes to the server. That's it. Get them to the server, define the path, and restore and recover. That's it. Recover it. That you should know. In any database, that concept is same, but ways of doing could be different. Okay. So why it is taking so long? So let me refresh the current page. Okay, it has not touched any of this. So whenever there is an operation you have triggered, and if you want to cancel it, so you come here, you see this red button, right side. So yeah, the buttons are a little tricky, very small, and sometimes you may not be able to see them. But if you start working on the HANA, you'll read. So it is the cancel operation. So suppose if the process some error, so you can check it in the error log. Okay, and then you have the properties and the progress. You click on the progress tab. The current running transaction, whether it is running or not. So let's see if this. Okay, so while it is running, so is it useful now, HANA? Did you get a fair idea of what it is and how the architecture has helped to see this, guys? So this screen will come. Okay, now 3 options you have. So recover the database to its most recent state. Recover the database to the following point in time. Suppose if you want to give exactly the time to which you want to restore, you mention the date and time of this, if you know it. So if you want to recover to a specific data backup and storage snapshot, the one which we just took, right? It takes you to that backup, whatever the content that backup has up to that point. So 3 options. So in case of upgrades or in case of these things, it should be fine for you, because if you know that there is nothing happened after this, after this particular database, you can restore to that data backup. But in the cases unexpected failures, okay, for example, there are some 100 transports thrown into the system. You don't know which transport has caused it. And then the customers will tell you that, hey, take it to a particular point in time and see. So that time you define this time and then you define. So just 3 options you have. So, and then you press next. Okay. Then it will ask you to the backup location and the log location. So location, it will ask you, you just mention the location. I don't want to proceed further. That's it. Your system will come to that particular status. I canceled it. Okay. Clear? This is how you recover your system.